Some mysteries don't begin with discovery, they begin with doubt. The moment you realize something doesn't quite fit, but you can't explain why. That's where the ancient world pulls you in. Not with answers, but with contradictions. Precision without context. Knowledge without origin. Creations that feel less like experiments and more like echoes of something already perfected. And the deeper you follow those echoes, the more they seem to converge, quietly pointing toward a system, a logic, a way of understanding that no longer exists. It's not obvious, it's not direct, but it's there. And once you sense it, the question changes forever. Are we uncovering the past, or stepping into something that was never truly gone? Perched dramatically on the rim of an extinct volcano in northeastern Thailand, Phanom Rung Historical Park stands as one of the most extraordinary architectural achievements of the ancient Khmer civilization. Built between the 10th and 13th centuries during the height of the Khmer Empire, the temple complex was dedicated primarily to the Hindu god Shiva, and served both as a sacred pilgrimage site and a symbolic representation of Mount Meru, the mythical centre of the universe in Hindu cosmology. Yet beyond its religious significance, Phanom Rung has become an enduring subject of fascination for archaeologists and historians because of the remarkable engineering, astronomical alignment, and construction techniques embedded within its design. Features that still raise questions about how ancient builders achieved such precision with the limited tools of their era. The temple sits approximately 400 meters above the surrounding plains, positioned atop the remnants of a dormant volcanic cone that last erupted hundreds of thousands of years ago. From an engineering perspective, this location alone presents a formidable challenge. Most of the structure is built from sandstone blocks that were quarried from locations estimated to be more than 50 kilometers away. Archaeological surveys conducted by the Thai Fine Arts Department in the 1970s and 1980s suggest that many of these blocks weigh several hundred kilograms, with some reaching close to a metric ton. Transporting such heavy materials across long distances and then hauling them up a steep volcanic hill would have required an advanced logistical system. Some scholars have proposed that wooden sledges, elephant labour and earthen ramps might have been used. But unlike the well-documented ramp systems discovered near the Great Pyramid of Giza, no definitive archaeological evidence of large transport ramps has been found around Phanom Rung. This absence of clear construction infrastructure has fueled ongoing debate about the exact methods used by Khmer engineers nearly 1,000 years ago. Equally impressive is the precision with which the temple's sandstone blocks were carved and assembled. Many walls within the sanctuary are constructed without the use of mortar, relying instead on carefully shaped stones fitted tightly together. Even today, the seams between some blocks are so narrow that inserting a thin blade is nearly impossible. This technique resembles the remarkable stone-fitting methods seen at Sacsayhuaman in the Andes, where massive stones were cut and interlocked with astonishing accuracy centuries before modern surveying equipment existed. The similarity has often led researchers to question whether ancient builders in different parts of the world independently developed comparable engineering principles to achieve long-lasting structural stability. Despite centuries of tropical weather, seasonal monsoon rains, and minor seismic activity, much of Phanom Rung's core architecture remains structurally sound, testimony to the effectiveness of its original design. However, the most astonishing feature of Phanom Rung, and the aspect that continues to intrigue scientists the most, is its extraordinary astronomical alignment. The temple complex is built along a long axial pathway, stretching from the grand eastern entrance toward the central sanctuary. Along this path stand a series of 15 doorways aligned in a perfectly straight line. during specific days of the year when the position of the sun coincides precisely with the orientation of the temple's axis. Sunlight passes directly through all 15 doorways at once, creating a glowing corridor of light that runs through the heart of the structure. This rare phenomenon occurs 4 times each year, twice during sunrise and twice during sunset, when the sun's position aligns with the temple's east-west axis. On these days, the rising or setting sun appears perfectly framed within the sanctuary, illuminating the inner chamber with a dramatic beam of light that seems almost deliberately engineered for ceremonial effect. Modern astronomical calculations indicate that achieving such an alignment would require extremely accurate measurements of solar movement along the horizon. The Earth's axial tilt causes the sun's rising and setting points to shift throughout the year, meaning the builders had to understand the seasonal path of the sun in order to align the temple correctly. Scholars studying the site have suggested that Khmer architects may have observed solar cycles for many years, possibly decades, before finalizing the layout of the temple. Excavations and restoration work carried out during the late 20th century revealed that the entire complex is oriented approximately 5 degrees north of due east, a slight adjustment that appears to have been intentionally designed to produce the famous 15-door alignment effect. Such precision suggests not only architectural skill, but also a sophisticated knowledge of astronomy. The phenomenon has often been compared to the solar alignments of Stonehenge, where the rising sun during the summer solstice aligns with the heel stone and the central axis of the monument. Similar solar engineering can also be seen in Mesoamerican structures like El Castillo, Temple of Kukulkan, where shadows during the equinox create the illusion of a serpent descending the pyramid staircase. Yet what makes Phanom Rung unique is the sheer number of architectural elements involved in the alignment. 15 separate doorways, each constructed at different stages of the temple's development, had to remain precisely aligned across a distance of nearly 300 meters. Even a small deviation of a few centimeters in any doorway could disrupt the effect entirely. The fact that the phenomenon still occurs today indicates that the builders achieved a level of geometric accuracy that rivals modern surveying methods. Archaeological investigations conducted throughout the 20th century have attempted to determine whether the alignment was intentional or merely coincidental. In 1971, Thai archaeologists began systematic restoration of the complex, carefully reconstructing collapsed sections using a method known as anastylosis, reassembling original stones in their original positions. During this process, researchers confirmed that the alignment was embedded within the original architectural plan rather than the result of later modifications. Additional studies using satellite imagery and digital modelling in the early 21st century have further confirmed that the temple's axis corresponds precisely with the solar events observed today. These findings strongly suggest that the builders intentionally designed Phanom Rung as both a religious sanctuary and a symbolic solar monument. Despite these discoveries, many questions remain unanswered. Historians still debate how Khmer architects measured solar angles with such precision in an era before telescopes, compasses, or modern mathematical instruments. Some theories propose the use of simple gnomons, vertical sticks used to track shadows, but achieving the accuracy required for the 15-door alignment would likely demand long-term observational records and advanced geometric planning. Others suggest that the alignment may have had ritual significance tied to the worship of Shiva, possibly symbolizing the passage of divine energy through the temple during certain celestial events. Yet no surviving inscriptions at the site clearly explain the builder's intentions. How do you think ancient builders were able to align 15 doorways so precisely with the movement of the sun nearly 1,000 years ago? Was it advanced observation of astronomy, lost engineering knowledge, or something we still don't fully understand? Where are you watching this video from and what time of day is it for you? Share your location and time in the comments below. The Tanit Temple of Kerkouane in Tunisia stands among the most intriguing surviving religious structures of the ancient Punic world. Located inside the remarkably well-preserved Punic city of Kerkouane on the Cap Bon Peninsula, this sanctuary was dedicated to the powerful Carthaginian goddess Tanit, a deity associated with fertility, protection, and celestial power in the civilization of Carthage. What makes the temple particularly fascinating is not merely its religious symbolism but the surprising engineering sophistication embedded within its construction. Despite being built more than 2,000 years ago, most likely between the 4th and 3rd centuries BCE, the structural remains reveal an advanced Punic building technology whose durability continues to puzzle archaeologists today. Among all the mysteries surrounding the site, the most remarkable involves the unusually resilient stone and brick construction techniques used by Punic builders, techniques that allowed the sanctuary's foundations and walls to survive in a harsh coastal environment where many ancient structures would normally have deteriorated long ago. The ruins of Kerkouane were first systematically identified in the early 20th century, with major excavations conducted during the 1950s and 1960s by French and Tunisian archaeological teams. Unlike many ancient cities of North Africa that were later rebuilt by Roman settlers, Kerkouane was abandoned after its destruction during the First Punic War and was never significantly reoccupied. Because of this unusual historical circumstance, the archaeological layers remained relatively undisturbed, allowing researchers to study a Punic city in a state close to its original condition. Within this preserved urban layout, the Tanit Temple appears as a sacred complex integrated into a carefully planned neighbourhood of houses, workshops, and ritual spaces. Excavations uncovered stone altars, courtyards, and foundations constructed with a combination of limestone blocks, fired bricks, and a distinctive lime-based mortar, whose composition has become one of the most intriguing technological puzzles of the site. One of the first observations made by archaeologists studying the temple was the exceptional stability of its construction materials. Kerkouane lies only a short distance from the Mediterranean shoreline, an environment characterized by salt-laden winds, seasonal humidity, and strong coastal erosion, conditions that typically accelerate the decay of ancient masonry. Yet the walls and foundations of the Tanit sanctuary remain surprisingly intact, even after more than 2 millennia. In several sections of the temple complex, the stone blocks retain their original alignment with minimal displacement, suggesting that the builders employed a construction method capable of resisting both environmental degradation and ground movement. Laboratory analyses of mortar samples conducted during archaeological studies in the late 20th century revealed a mixture dominated by lime and finely crushed aggregates, possibly including marine sand and mineral additives. Although the exact proportions are still debated, some researchers believe that the Punic masons may have developed a specialized mortar designed to withstand moisture and salt infiltration. This discovery has led to comparisons with another famous ancient building technology, the hydraulic concrete used by the Romans centuries later. Roman maritime structures, such as the harbour installations at Portus, are known to have relied on volcanic ash and lime to create a durable concrete capable of hardening underwater. While the Punic builders at Kerkouane did not produce concrete in exactly the same form, the resilience of their masonry suggests a similar understanding of mineral chemistry. Some archaeologists have proposed that the lime mortar used in the Tanit Temple may have included naturally reactive materials that increased its strength over time. If this hypothesis is correct, the Punic engineers may have possessed empirical knowledge of long-lasting construction compounds long before Roman engineers refined comparable techniques. Equally intriguing is the precise arrangement of stone blocks within the temple's structural framework. Many of the surviving walls display carefully cut limestone blocks laid in tight horizontal courses with minimal gaps between them. Measurements conducted during architectural surveys indicate that the alignment of certain foundation lines deviates by only a few centimetres across several metres of wall length, a level of precision that implies deliberate planning and skilled craftsmanship. For comparison, similar levels of stone block accuracy are often associated with monumental Mediterranean structures, such as the Greek temples at Temple of Hera at Paestum. Yet the Punic sanctuary at Kerkouane was built in a relatively modest urban environment, rather than as an enormous monumental complex. This raises an important question. How did Punic builders achieve such geometric consistency, using the relatively simple tools available during the classical period? Another remarkable feature of the Tanit temple is the integration of stone construction with fired brick elements. Archaeologists discovered that certain interior structures and partitions were built from rectangular bricks, bonded with lime mortar, forming stable surfaces that complemented the heavier limestone foundations. This hybrid technique appears to have provided both structural strength and architectural flexibility. In several sections of the sanctuary, bricklayers were used to create level platforms or raised ritual spaces around altars. Because fired bricks are lighter than large stone blocks, their use would have reduced stress on the foundation, while still allowing builders to construct elevated ceremonial features. Interestingly, the dimensions of the bricks discovered at Kerkouane appear relatively standardized, suggesting the existence of organized production methods within the Punic city. Excavations conducted in the 1970s and later decades also revealed drainage channels and small basins near the temple courtyard, indicating that the builders incorporated water management into the design of the sanctuary. These channels were carved into stone or lined with masonry, and appear to have been carefully angled to guide water away from the ritual areas. Although the slopes are subtle, often only a few degrees, they are sufficient to ensure steady drainage during rainfall. This demonstrates that Punic architects understood the importance of protecting sacred structures from water accumulation, which could weaken foundations over time. Such attention to environmental durability further emphasizes the technical sophistication behind the temple's construction. In addition to structural engineering, the temple complex contains symbolic carvings associated with the goddess Tanit. The well-known Tanit symbol, often depicted as a triangular figure topped by a circle and crossed by a horizontal bar, appears on stones and ritual surfaces throughout the site. These engravings are cut with notable consistency and depth, suggesting that artisans used hardened metal chisels capable of carving precise lines into limestone. While iron tools were available during the Punic period, relatively few examples have been recovered from the site, leaving open questions about the exact techniques used to produce these carvings. Perhaps the greatest archaeological mystery surrounding the Tanit temple arises from the abrupt historical fate of Kerkouane itself. During the First Punic War between Rome and Carthage, the city was likely destroyed or abandoned around the middle of the 3rd century BCE. Unlike Carthage, which was later rebuilt and transformed into a major Roman centre, Kerkouane was never extensively resettled. As a result, its buildings, including the Tanit sanctuary, remained frozen in time beneath layers of sand and soil. When archaeologists uncovered the site centuries later, they encountered an unusually intact Punic urban landscape, providing a rare glimpse into a civilization that left few written architectural records. What secret building technology might the Punic engineers have known that we still don't fully understand today? Tell us your theory in the comments below. High above the dry savanna landscapes of central Tanzania lies one of Africa's most enigmatic archaeological treasures, the Kondoa rock art sites. Scattered across the rocky hills of the Kondoa-Irangi region, this vast complex contains more than 200 decorated rock shelters, some hidden deep within sandstone cliffs, and others overlooking valleys that have changed little since prehistoric times. At first glance, these paintings appear simple. Figures of hunters, animals, ritual dancers, and geometric symbols painted in shades of red and white. Yet behind their apparent simplicity lies a technological mystery that has puzzled archaeologists, chemists, and historians for decades. How did prehistoric people create pigments capable of surviving on exposed rock surfaces for thousands of years? Archaeological research suggests that the earliest paintings in Kondoa may date back as far as 10,000 years, produced by hunter-gatherer communities who once inhabited the region, long before pastoral societies arrived. Later layers of art, sometimes painted directly over earlier images, indicate that the shelters continued to be used for ritual or symbolic purposes for millennia. Excavations conducted throughout the 20th century, particularly during surveys in the 1950s and 1960s, revealed stone tools, hearth remains, and fragments of ochre pigment scattered across habitation floors beneath the painted walls. These discoveries confirm that the shelters were not merely galleries but active living spaces where people gathered, prepared materials, and likely performed ceremonies connected to the imagery above them. Among all the mysteries surrounding Kondoa, the most astonishing is the extraordinary durability of its pigments. The majority of the paintings were created using red ochre, a naturally occurring iron oxide mineral widely used by prehistoric cultures around the world. In theory, ochre alone should not survive for such immense periods when exposed to rain, sunlight, and temperature fluctuations, yet many Kondoa paintings remain strikingly visible today, their red tones still vivid against pale sandstone surfaces even after thousands of years of environmental exposure. For comparison, many modern paints applied to outdoor stone structures begin fading within only a few decades, or even some industrial pigments designed for architectural durability rarely remain intact for more than a few centuries without restoration. The survival of Kondoa's prehistoric pigments therefore raises a compelling technological question. What formula allowed ancient artists to produce such long-lasting colour? Scientific investigations have attempted to answer this question by analysing microscopic samples from the paintings. Studies carried out during conservation programs in the late 20th century found that the pigments contained finely ground hematite particles, the iron-rich mineral responsible for the deep red colour of ochre. However, mineral pigment alone cannot explain the remarkable adhesion observed in Kondoa paintings, or in many locations the colour does not simply sit on the rock surface, but appears to have penetrated slightly into the sandstone itself, forming a thin but resilient layer that resists erosion. This suggests that prehistoric artists likely mixed the mineral powder with organic binders capable of strengthening the pigment and helping it bond with the rock. Researchers have proposed several possible binding agents, including animal fat, plant resin, egg proteins, or blood. Similar organic mixtures have been documented in prehistoric art elsewhere, such as the famous cave paintings of Lascaux in France or Altamira in Spain. However, Kondoa presents a unique challenge for scientists. After thousands of years in a tropical climate, most organic compounds would have degraded completely, leaving only faint chemical traces that are difficult to identify. As a result, no definitive recipe has been confirmed. The exact mixture used by Kondoa's ancient artist remains unknown, making it one of the most intriguing technological puzzles in prehistoric art. Another factor contributing to the preservation of these paintings may be the geological properties of the rock shelters themselves. Many of the artworks were created beneath natural overhangs that protect them from direct rainfall. The sandstone surfaces also possess a slightly porous texture, which may have allowed pigments mixed with liquid binders to seep into microscopic cavities before hardening. Over time, mineralization processes could have further stabilized the pigment layer, effectively sealing the color into the stone. Even with these protective factors, however, the longevity of the images still exceeds what scientists typically expect from prehistoric materials. The paintings themselves provide additional insight into the societies that created them. Many scenes depict hunters pursuing animals such as antelope, giraffes, or elephants, suggesting that the earliest artists were part of mobile hunting groups who relied on wildlife for survival. Other panels show rows of human figures dancing or holding hands, possibly representing communal rituals or spiritual ceremonies. Particularly fascinating are abstract geometric patterns, circles, grids, and intersecting lines that appear repeatedly across multiple shelters. These motifs may have held symbolic meaning, perhaps connected to cosmology, territory, or memory systems used by early communities. Archaeological evidence indicates that the Kondoa shelters were used by several cultural groups over time. The earliest paintings are often attributed to ancient hunter-gatherers, related to the ancestors of modern San peoples of southern Africa. Later artwork may have been produced by pastoral communities who migrated into the region several thousand years ago. Even today, the local Sandawe people maintain oral traditions that link some of the paintings to ritual practices involving trance dances and spiritual communication. While these traditions cannot directly explain the oldest images, they suggest a long continuity between ancient symbolic art and living cultural heritage. The scale of the Kondoa rock art landscape further adds to its mystery. Spread across a region covering hundreds of square kilometers, the painted shelters form an immense open-air archive of human creativity spanning many millennia. In 2006, the site was officially recognized as a UNESCO World Heritage Site due to its exceptional cultural significance. Conservation efforts now focus on protecting the fragile artworks from weathering, vandalism, and modern environmental pressures. Yet despite decades of research, one question continues to fascinate scientists and historians alike. How did prehistoric artists, working with stone tools and natural minerals, manage to create pigments that have endured for thousands of years? In the silent shelters of Kondoa rock art sites, the secret remains hidden within ancient pigments. The red figures of hunters and dancers still survive after thousands of years, preserved by a technique that science has not fully understood. Whether through organic binders, mineral chemistry, or unique environmental conditions, the artist of Kondoa created images that have outlived the civilizations that made them. What do you think allowed the paintings at Kondoa to survive for thousands of years? Share your thoughts in the comments below. Monte Verde, located in southern Chile near the modern city of Puerto Montt, is one of the most controversial and fascinating archaeological sites ever discovered in the Americas. For decades, scientists believe that the first humans arrived in the New World roughly 13,000 years ago, associated with the famous Clovis culture of North America. According to this traditional model, small groups of hunters migrated from Siberia into Alaska, across the Bering Land Bridge during the last ice age, and gradually spread southward through an ice-free corridor in Canada. However, the discoveries at Monte Verde have forced archaeologists to reconsider this entire narrative. Excavations led by American archaeologist Tom Dillahay beginning in the late 1970s revealed a remarkably well-preserved settlement buried beneath layers of peat and sediment. Radiocarbon dating of charcoal, wooden structures, animal bones, and plant remains consistently produced ages of around 14,500 years, placing the site at least 1,000 years earlier than the Clovis culture and thousands of kilometers farther south. The implications were extraordinary. If humans were already living in southern Chile 14.5 millennia ago, They must have entered the Americas far earlier than previously believed. What makes Monte Verde particularly unique is the exceptional preservation of organic materials rarely found in archaeological sites of such antiquity. Because the camp was eventually covered by waterlogged peat, delicate objects such as wooden tools, plant fibres, and fragments of animal hide survived for thousands of years. Archaeologists uncovered the remains of a long communal structure, roughly 20 metres in length, supported by wooden posts and likely covered with animal skins or plant materials. This shelter appears to have been divided into multiple sections, possibly housing several families. Nearby, researchers found hearths, cooking areas, and scattered tools made from stone, bone, and wood. The level of organisation suggests a community that understood how to construct durable shelters and manage shared living spaces, even in the cold and wet conditions of the late Ice Age. Such evidence challenges the stereotype that early hunter-gatherers in the Americas lived only in temporary camps with minimal technology. Another remarkable discovery at Monte Verde involves the wide range of plant remains recovered from the site. Researchers identified more than 45 different species, including edible plants, medicinal herbs, and even seaweed transported from the Pacific coast, approximately 60 kilometers away. The presence of coastal seaweed so far inland suggests that the inhabitants either traveled long distances or maintained connections with groups living near the ocean. Some of these marine plants possess natural antibacterial properties, leading scientists to speculate that the people of Monte Verde may have had early knowledge of medicinal resources. Compared with other Ice Age camps in North America, which often yield primarily stone tools and animal bones, Monte Verde reveals a far more complex picture of human adaptation, diet, and ecological knowledge. Yet the most profound mystery surrounding Monte Verde lies not in the artifacts themselves, but in the question of how these early people arrived there in the first place. The traditional Clovis first theory once suggested that humans entered North America around 13,000 years ago and slowly migrated southward through an ice-free corridor between massive glaciers covering much of Canada. But Monte Verde's confirmed age of about 14,500 years makes that scenario difficult to explain. If people had already reached southern Chile by that time, they would have had to travel nearly 15,000 kilometers from Alaska in a relatively short period. Moreover, geological evidence indicates that the supposed ice-free corridor may not have been fully passable until around 13,000 years ago, meaning it might not have been available when the Monte Verde settlement was already thriving. This contradiction has led many researchers to consider an alternative hypothesis known as the Pacific Coastal Migration Route. According to this theory, the first Americans may have traveled along the western coastline of the Americas by following marine ecosystems rich in fish, shellfish, and sea mammals. Small groups could have moved gradually southward using simple watercraft or by travelling along beaches and coastal plains that existed during the lower sea levels of the Ice Age. In this model, people could have spread rapidly along the Pacific Rim, reaching regions as far south as Chile much earlier than previously imagined. Supporters of this idea point to the discovery of coastal resources at Monte Verde, such as seaweed and marine plants, as possible indirect evidence that early settlers were familiar with coastal environments. However, proving the coastal migration theory is extremely difficult. At the end of the last Ice Age, rising sea levels submerged vast stretches of ancient shoreline under the Pacific Ocean. Many of the campsites that early travellers might have used are now underwater, making them nearly impossible to locate. This means that Monte Verde remains one of the few surviving clues to a much larger and mostly invisible migration story. And as some archaeologists have suggested that if similar sites could be discovered along ancient coastal routes in North or Central America, they might provide stronger evidence for this early maritime movement. The debate surrounding Monte Verde intensified during the 1990s, when a group of leading archaeologists visited the site to examine the evidence directly. Initially skeptical, many of them were eventually convinced by the quality of the data, including carefully documented excavation layers and consistent radiocarbon dates. In 1997, Monte Verde was widely accepted as a legitimate pre-Clovis site, fundamentally altering the timeline of human settlement in the Americas. Since then, additional research has hinted that even older layers may exist at the site, sometimes referred to as Monte Verde I, which could date back as far as 18,000 years. If these earlier levels are confirmed, they would push the human presence in South America even further into the past, deepening the mystery of how and when the first people arrived. In comparison with other famous early sites in the Americas, Monte Verde stands out both for its age and for its extraordinary preservation. Sites associated with the Clovis culture, such as those found in the United States and Canada, are typically characterized by distinctive fluted spear points used for hunting large Ice Age animals. Monte Verde, by contrast, contains a much more diverse collection of tools and materials, reflecting a broader adaptation to forests, rivers, and coastal ecosystems. This difference suggests that early American populations may have been more culturally and technologically diverse than once believed. Monte Verde challenges long-held ideas about when and how humans first reached the Americas. The site suggests that people may have travelled vast distances and adapted to new environments much earlier than once believed. Yet the biggest mystery remains. How did these ancient travellers reach southern South America so early? Whether by coastal journeys, inland routes, or paths still unknown, Monte Verde remains one of the most intriguing puzzles in human history. In your opinion, which seems more plausible, that ancient humans migrated along the Pacific coast using primitive boats, or that they reached the Americas through a completely different route that science has not yet discovered? Share your thoughts in the comments below. Rising from the small Mediterranean island of Malta, the megalithic temples of Tarxien remain one of the most astonishing prehistoric engineering achievements ever discovered. Located near modern-day Valletta, the complex was first uncovered in the year 1914, when local farmers accidentally exposed massive stone blocks while ploughing their fields. Archaeological excavations soon followed under the direction of Maltese archaeologist Themistocles Zammit, revealing an elaborate ceremonial site constructed between roughly 3,600 and 2,500 BCE. This means the Tarxien complex is older than the Great Pyramid of Giza by nearly 1,000 years, placing it among the earliest monumental stone structures on Earth. The temples belong to a unique tradition of megalithic architecture found across Malta, including sites such as Hagar Kim and Najdra. Yet Tarxien stands out for its extraordinary complexity, rich decoration, and above all the perplexing engineering required to move and position enormous limestone blocks long before the invention of metal tools or wheel transport. At the heart of the mystery lies a simple but staggering question. How were the enormous stones of Tarxien moved into place? Many of the megaliths used in the temples weigh between 10 and 20 tons, with some reaching heights of more than 3 meters. These blocks form curved walls, massive doorways, and intricate internal chambers arranged in a clover-shaped architectural layout typical of Maltese prehistoric temples. Moving stones of this size would be challenging even with modern equipment, yet the builders of Tarxien achieved it more than 5,000 years ago, with technologies that appear, at least on the surface, extremely limited. Archaeologists have found no evidence that the people of prehistoric Malta possessed iron tools, large draft animals, or even the wheel at the time the temples were constructed. In fact, the wheel did not appear in Europe until roughly 2,000 years later. This technological gap has led researchers to investigate alternative explanations for how such massive stones could have been transported across the landscape. One of the most intriguing clues emerged during excavations when archaeologists discovered spherical limestone balls scattered near the temple complex. These objects, often about 10 to 15 centimeters in diameter, resemble primitive ball bearings. Some researchers believe that the builders of the Tarxien temples may have placed these stone spheres beneath heavy slabs to create a rolling platform, allowing large blocks to move more easily across prepared tracks. Experiments conducted by modern engineers have shown that similar systems can indeed reduce friction dramatically, making it possible for a relatively small group of people to move multi-ton stones. However, the exact method remains uncertain. While the spheres suggest a form of prehistoric engineering ingenuity, archaeologists have not yet found definitive evidence proving precisely how the system was organized, or whether it could reliably handle the largest stones in the complex. Furthermore, Malta's terrain raises additional questions. The island lacks extensive forests, meaning that the builders had limited access to large quantities of timber that might have been used for sledges, rollers, or scaffolding. This scarcity makes the logistics of transporting multi-ton stones across even short distances even more puzzling. Comparisons with other ancient megalithic sites highlight just how remarkable Tarxien's construction truly is. At Stonehenge, for example, some stones weighing around 25 tons were transported from quarries hundreds of kilometers away, likely using sledges and wooden rollers. Yet Stonehenge was built more than 1,000 years after Tarxien, and in a region rich in timber resources. Similarly, the Great Pyramid of Giza involved the movement of limestone blocks weighing several tons each, but Egyptian builders had access to copper tools, or organized labor forces numbering in the thousands, and sophisticated ramp systems. In contrast, the prehistoric society that constructed Tarxien appears to have been relatively small and technologically simple. Malta itself was never a vast civilization with massive populations. Estimates suggest that the entire island may have supported only a few thousand inhabitants during the temple building period. This raises another profound mystery. How could such a small community mobilize the labor and technical knowledge required to construct such monumental architecture? Archaeological investigations throughout the 20th century have revealed that Tarxien actually consists of 4 interconnected temples, each constructed during different phases over several centuries. Excavations carried out in the 1920s and later decades uncovered elaborate stone altars, carved reliefs, and fragments of colossal statues. Among the most famous discoveries is the lower half of a gigantic limestone statue believed to represent a fertility goddess, once standing more than 2.5 meters tall. The statue's finely carved drapery and smooth surfaces demonstrate a level of craftsmanship that seems surprisingly advanced for a Neolithic culture using stone tools. Yet the artistry of Tarxien extends far beyond sculpture. Many of the temple walls are decorated with intricate spiral carvings, among the most sophisticated prehistoric stone engravings ever discovered in Europe. These spirals are deeply incised into limestone slabs, arranged in repeating patterns that suggest careful planning and artistic tradition. Equally impressive is the architectural precision of the complex. The temples are arranged along a central axis and organized into symmetrical chambers connected by narrow passageways. Massive upright stones form doorways leading into apsidal rooms where ritual altars once stood. Some of these stones were shaped with surprising accuracy, creating smooth surfaces and carefully aligned edges. Archaeologists have noted that many of the blocks appear to have been carefully dressed and fitted together, suggesting an advanced understanding of stoneworking techniques. Even today, the walls maintain their structural integrity despite thousands of years of weathering. This durability indicates that the builders understood how to select suitable limestone and how to distribute weight effectively within the structure. Evidence discovered during excavations also suggests that Tarxien served as an important ritual and ceremonial centre. Animal bones found near altars indicate that sacrifices were performed within the temples, possibly as part of fertility or seasonal ceremonies. Some archaeologists have proposed that the complex functioned as a sacred space where communities gathered for religious events, reinforcing social cohesion in prehistoric Maltese society. However, the exact belief system of the temple builders remains unknown, as they left behind no written records. Without texts or inscriptions, researchers must rely entirely on physical evidence to reconstruct the meaning of the site. Despite more than a century of research, the greatest enigma of Tarxien continues to revolve around its engineering. The transportation and placement of enormous stones remain only partially understood, and every new excavation seems to raise further questions. In recent years, advanced technologies such as laser scanning and three-dimensional modelling have allowed archaeologists to study the temples with unprecedented precision. These studies reveal subtle construction patterns and possible quarry sources for some of the stones, but they still do not fully explain how the builders managed the logistics of moving such massive blocks. What Tarxien ultimately demonstrates is that prehistoric societies may have possessed far more sophisticated engineering knowledge than we once believed. How do you think the builders of the Tarxien temples managed to move stone blocks weighing dozens of tons more than 5,000 years ago? Share your thoughts or theories in the comments below. Across the arid valleys and rocky hills of central Iran lies one of the most enigmatic rock art landscapes on Earth, the Teymareh petroglyphs, a vast open-air gallery of prehistoric engravings scattered across the region between Golpayegan and Kerkouane. At first glance, the rocks appear ordinary, weathered by centuries of wind and desert sun, yet carved into their dark surfaces are thousands of ancient images, animals, hunters, geometric symbols and mysterious figures, etched by human hands long before written history. Archaeologists consider Teymareh one of the most important rock art regions in the Middle East, containing a massive collection of engravings created across multiple prehistoric eras. Some estimates suggest that the earliest carvings here may date back thousands of years, and possibly even earlier, making the site one of the oldest known centres of rock art in Iran. The scale of the site itself is staggering. Instead of a single cave or monument, the petroglyphs are spread across a broad mountainous landscape, appearing on isolated boulders, cliff faces, and exposed rock panels scattered throughout the valley. Many of these stones contain clusters of engravings layered on top of each other, suggesting that generations of ancient peoples returned to the same places repeatedly over centuries or even millennia. Among the most common images are animals, particularly the ibex, a wild mountain goat whose long curved horns dominate the rock art of Iran. In fact, studies show that nearly 88% of Iranian petroglyph imagery depicts the ibex, a striking statistic that reveals how central the animal was to the beliefs and survival of early societies in the region. Yet despite the abundance of familiar themes like hunting scenes and animal figures, the true mystery of Teymareh lies in the techniques used to create these carvings and the symbolism they contain. Ancient artists carved deep grooves into extremely hard rock surfaces, using primitive tools such as flintstones, bones, or later metal implements. Achieving clean, continuous lines in such material would have required enormous patience and precision. In some panels, the lines are so smooth and deliberate that they appear almost modern, raising questions about how prehistoric craftsmen were able to maintain consistent depth and symmetry while working with crude tools. Now, compared with other famous rock art sites, such as the petroglyphs of the Sahara or the Bronze Age carvings of Scandinavia, the engravings of Teymareh often display a surprising level of detail, especially in the depiction of animals and ritual scenes. Over the past decades, Iranian archaeologists and rock art specialists have conducted several surveys across the region, mapping thousands of images and documenting their patterns. These studies suggest that the valley may once have served as an important cultural corridor for prehistoric communities moving through the Iranian plateau. The repeated appearance of similar motifs across large distances hints that the site was not merely a random collection of carvings, but perhaps a symbolic landscape where ancient people recorded events, rituals, or mythological beliefs. In many ways, Teymareh resembles a prehistoric archive, an enormous stone chronicle documenting the lives and ideas of civilizations that left no written records. But among all the engravings discovered in this vast archaeological field, one particular image stands apart from the rest and has captured the attention of scientists around the world. During a survey conducted between 2017 and 2018, researchers studying the rock art of Teymareh identified a small but astonishing carving unlike anything previously documented at the site. Measuring roughly 14 centimeters in length, the engraving depicts a strange creature with 6 limbs and distinctive raptorial forearms, the unmistakable posture of a praying mantis. At first, archaeologists struggled to interpret the figure. Insects are rarely depicted in prehistoric petroglyphs anywhere in the world, and the creature's posture appeared almost unnatural. To understand what they were seeing, the researchers collaborated with entomologists who compared the image with local species of insects. Their analysis revealed that the carving closely resembled a mantis belonging to the Empusa group, recognizable by its elongated body and folded predatory arms. Yet the carving was not simply an insect. It also contained features resembling human symbolism, circular shapes on both sides of the body that resemble the famous squatter man motif, a mysterious symbol found in petroglyphs across several continents. This extraordinary hybrid image, part insect, part symbolic human figure, has since been nicknamed the Mantis Man. Some researchers describe it as a prehistoric fusion of a praying mantis and a humanoid form, a concept that has rarely appeared in ancient art. The discovery raised immediate questions. Why would prehistoric artists carve such a creature? Was it meant to represent a real insect observed in nature, or was it part of a mythological belief system now lost to time? Because mantises are known for their unusual appearance and predatory stance, some scientists speculate that ancient people may have considered them spiritually significant or even supernatural. Another intriguing theory connects the carving with global rock art traditions. The circular shapes flanking the mantis resemble symbols seen in the squatter man motif, which appears in rock art from regions as distant as Europe and North America. Some researchers believe these symbols may represent cosmic or atmospheric phenomena, possibly ancient observations of auroras or celestial events, interpreted through mythological imagery. If this interpretation is correct, the Teymareh carving could represent a fusion of natural observation and symbolic cosmology, capturing how prehistoric people understood the forces of the universe. What makes the discovery even more puzzling is its rarity. While animals such as ibex, deer, and horses appear frequently in ancient rock art, insect imagery is almost non-existent. The mantis carving therefore represents a unique example of cultural entomology in prehistoric art, suggesting that even small creatures could inspire symbolic or religious imagery among ancient societies. Some scholars propose that the mantis, with its distinctive posture resembling folded arms, may have been interpreted as a meditative or sacred figure. Others suggest that the creature's predatory nature may have symbolized power, transformation, or spiritual guardianship. Despite these fascinating hypotheses, the true meaning of the mantis man remains unknown. The carving offers no accompanying symbols or inscriptions that might explain its significance. Like many petroglyphs around the world, it exists as a silent message from a vanished culture, a fragment of thought preserved in stone but stripped of the context needed to fully understand it. Archaeologists can analyze its shape, compare it with other symbols, and estimate its age, yet the intention behind it may forever remain beyond our reach. In this sense, the Teymareh petroglyphs represent more than just ancient artwork. They are evidence of how early humans attempted to record their experiences, beliefs, and encounters with the natural world. Long before the invention of writing, prehistoric communities used stone as their canvas and memory. Each engraving, whether a hunting scene, a geometric symbol, or a strange creature like the mantis man, served as a message carried across thousands of years. So what do you think the mantis man carving truly represents? A mythical creature, an ancient spiritual symbol, or something that modern science still cannot fully explain? Share your thoughts in the comments below. The Trelleborg Viking ring fortress, Denmark, is one of the most fascinating archaeological sites associated with the Viking Age, and it continues to challenge modern understanding of early medieval engineering and planning. Located near the town of Slagelse on the island of Zealand, Trelleborg was first discovered in the late 1930s when Danish archaeologist Paul Nørlund began systematic excavations at the site in 1934. What he uncovered was not merely the remains of a Viking fortification, but a structure whose mathematical precision and geometric design seemed astonishingly advanced for its time. Today, Trelleborg is considered one of several ring fortresses built during the reign of the Danish king Harald Bluetooth around the late 10th century, roughly between 970 and 980. Now, yet despite decades of research, many aspects of its construction still puzzle archaeologists and historians. The most striking and mysterious feature of Trelleborg is its almost perfectly circular design. The fortress forms a near-perfect ring with a diameter of roughly 137 meters, enclosed by a massive earthen rampart approximately 17 meters thick at its base. When modern archaeologists conducted precise surveys using contemporary measuring tools, they discovered that the deviation from a true circle is extremely small, only a few tens of centimeters across the entire circumference of more than 400 meters. Such accuracy is remarkable even by modern construction standards, yet this structure was created more than 1,000 years ago by Viking builders who lacked metal surveying equipment, optical instruments, or modern geometry tools. This level of geometric precision raises one of the central mysteries of Trelleborg. How did Viking engineers manage to construct such a precise circular structure on this scale? Creating a perfect circle with a diameter of over 100 meters requires careful measurement and consistent geometry. Even minor errors in distance or alignment would gradually distort the shape. Many early medieval fortifications across Europe were irregular in form because they followed natural terrain features. For example, contemporary defensive settlements in Anglo-Saxon England or Carolingian territories often adapted their walls to hills or rivers, resulting in asymmetrical shapes. Trelleborg, by contrast, appears almost as if it were drawn with a giant compass. Some researchers have proposed that the builders may have used a central stake with a long rope attached to trace the circular rampart. While this method can theoretically produce a circle, maintaining consistent tension and measurement accuracy over such a large radius would have been extremely difficult. The terrain would also have introduced irregularities, yet the final structure suggests that the builders maintained a remarkably consistent radius throughout construction. This has led some archaeologists to speculate that Viking planners may have possessed a more advanced understanding of practical geometry and land surveying than previously believed. Another mystery connected to the circular design is the precise positioning of the fortress gates and internal layout. where Trelleborg contains 4 main gates placed at exactly opposite points on the circle, aligned with the cardinal directions north, south, east and west. 2 main wooden roads cross the fortress from gate to gate, forming a perfect cross that divides the interior into 4 equal quadrants. Each quadrant originally contained 4 identical Viking longhouses, bringing the total to 16 buildings arranged in symmetrical patterns. The geometric organization of the site is so orderly that it resembles a planned military blueprint rather than an organically developed settlement. Archaeological excavations have confirmed that these houses were nearly identical in size and structure, typically around 30 meters long and 10 meters wide. Their placement follows strict spacing rules, reinforcing the idea that the entire fortress was built according to a centralized plan. This is highly unusual when compared with typical Viking villages, where houses were constructed gradually and irregularly as families expanded their homes or built new structures. Trelleborg instead suggests the presence of a coordinated construction project directed by powerful authority, likely connected to royal military strategy. Excavations carried out between 1934 and 1942 revealed the massive scale of the fortress ramparts. The circular wall consisted of packed earth reinforced with timber frameworks that helped stabilize the structure. Estimates suggest that constructing the rampart required tens of thousands of cubic meters of soil and large quantities of oak timber. Some calculations indicate that more than several thousand trees may have been needed to build the wooden structural elements and internal roadways. Organizing the cutting, transport, and installation of this material would have required a highly organized workforce and logistical planning, something rarely associated with Viking societies in traditional historical narratives. Interestingly, Trelleborg is not an isolated example. Archaeologists have identified several other Viking ring fortresses across Denmark and southern Scandinavia, including Aggersborg, Firkat and Nonnebakken. These fortresses share many of the same features: circular ramparts, 4 cardinal gates, cross-shaped internal roads, and symmetrical longhouse layouts. Aggersborg, for example, is even larger than Trelleborg, as measuring around 240 meters in diameter. The existence of multiple sites with such similar geometric designs suggests that they were constructed according to a standardized architectural concept, possibly ordered by the Danish crown during a period of military consolidation. Despite decades of research, however, historians still debate the true purpose of these fortresses. Some believe they were military barracks used to train and house Viking warriors before campaigns abroad. Others argue they functioned as administrative centres meant to consolidate royal control over newly unified territories. Whatever their purpose, the engineering precision of the ring fortresses continues to challenge assumptions about Viking technological capabilities. Perhaps the most intriguing question remains the simplest one. Who designed the geometry behind Trelleborg? The Vikings left very few written records, and none describe the planning of these fortresses. Without blueprints, manuals, or contemporary accounts, archaeologists must rely solely on physical evidence. Yet that evidence suggests that Viking builders were capable of executing large-scale construction projects with extraordinary geometric accuracy. More than 1,000 years later, Trelleborg still demonstrates the remarkable engineering skills of the Vikings. Its nearly perfect circular design and precise layout suggest a level of geometric knowledge that historians still cannot fully explain, making it one of the enduring mysteries of Viking technology. How do you think the Vikings over 1,000 years ago were able to build an almost perfectly circular fortress like Trelleborg? Was it simple measuring techniques, advanced knowledge of geometry, or something else we still don't fully understand? Share your thoughts in the comments below. Hidden beneath farmland on the western coast of Sardinia, lies one of the most extraordinary archaeological discoveries ever made in the Mediterranean, the giants of Monte Prama. These monumental stone statues were first uncovered in 1974 when a farmer near the village of Cabras accidentally struck fragments of carved limestone while ploughing his field. What began as a simple agricultural accident soon developed into one of the most significant archaeological excavations in Italian history. Over the following decades, archaeologists unearthed thousands of stone fragments that once formed dozens of towering statues, each standing roughly 2 to 2.5 meters tall. Radiocarbon dating and contextual analysis placed their creation around the 9th to 8th centuries before Christ. During the late phase of the Neurologic civilization, a Bronze Age culture unique to Sardinia. This dating is remarkable because it makes the Monte Prama statues the oldest known large-scale anthropomorphic stone sculptures in the Mediterranean, predating the famous Greek Kouroi statues by several centuries. Yet the most intriguing mystery of Monte Prama is not merely its age or scale, but the astonishing precision of its stone carving techniques. The statues represent warriors, archers, and boxers holding massive shields, bows, and protective armour. At first glance, their style appears stylized, almost geometric, but a closer examination reveals a level of technical control that continues to puzzle archaeologists and art historians alike. The most distinctive feature of these statues is their eyes, perfectly circular forms composed of 2 concentric rings carved deeply into the limestone. These circular eyes appear repeatedly across multiple statues, suggesting a standardized design tradition. What makes them extraordinary is the near-perfect symmetry of the circles. Even under modern measurement, the rings appear almost mathematically precise. For artisans working nearly 3,000 years ago, carving such consistent circular forms into stone would have required a remarkable level of control. Researchers examining tool marks on the statues have observed finely cut grooves that appear unusually uniform. Some archaeologists have suggested that Nuragic craftsmen may have used early geometric measuring tools similar to compasses or rotating guides to trace the circular eye patterns before carving them. While no such instruments have been discovered at the site, the hypothesis arises from the precision itself. Without a guiding device, maintaining such symmetry across dozens of sculptures would have been extremely difficult. Comparisons with other ancient stone carvings highlight the unusual nature of this precision. For instance, early Greek Kouroi statues carved centuries later typically show simplified eyes formed by almond-shaped outlines, rather than perfectly concentric circles. Similarly, Etruscan sculptures from mainland Italy, which date to roughly the same period as Monte Prama, rarely display such mechanically consistent circular forms. The Sardinian statues therefore appear to represent a distinct and surprisingly advanced sculptural tradition. Excavations carried out between 1975 and 1979 by the Italian Archaeological Superintendency revealed that the statues had originally been arranged near a vast Nuragic burial complex containing more than 100 tombs. Unfortunately, most of the sculptures had been deliberately shattered in antiquity. Archaeologists recovered more than 5,000 fragments scattered across the site, requiring decades of painstaking restoration. Beginning in the early 2010s, a major conservation project reconstructed more than 40 statues from these fragments. During this reconstruction process, researchers gained new insights into the carving methods used by the ancient artisans. The statues appear to have been carved from large blocks of local limestone extracted from nearby quarries several kilometers away. Each statue was composed of separate elements, including the torso, head, shield, and occasionally the arms. These pieces were carefully shaped and then assembled into a complete figure. Microscopic analysis of the stone surfaces suggests that the sculptors likely used bronze chisels and hammer stones to shape the limestone. However, the level of refinement achieved with these tools raises further questions. Bronze tools, while effective, tend to wear quickly when used on stone, particularly when creating sharp circular grooves like those seen in the statue's eyes and facial features. Yet the grooves appear crisp and deliberate with very little irregularity. Some researchers have proposed that artisans may have repeatedly sharpened their tools, or employed specialized chisels designed for fine carving. Another possibility is that teams of craftsmen worked systematically, each responsible for a specific stage of production, allowing the statues to be produced with remarkable consistency. The precision of Monte Prama also extends beyond the eyes. Facial proportions across multiple statues follow nearly identical ratios. The helmets, shields, and armour are carved with symmetrical lines and repeating patterns that suggest careful planning before carving began. In several reconstructed statues, the shields reach diameters of nearly 60 centimetres and are carved with smooth curved surfaces that appear almost machine-like in their regularity. Considering the limited technology of the Bronze Age, this raises an intriguing possibility that Nuragic artisans possessed a sophisticated understanding of geometry and proportional design. Archaeologists have attempted to compare Monte Prama with other large-scale stone sculptures of the ancient world. In Egypt, monumental statues were produced with advanced stoneworking techniques, but those sculptures belong to a civilization with centralized political organization and large labor forces. In contrast, the Nuragic civilization is generally thought to have been composed of smaller tribal communities centered around stone towers known as nurage. The ability of such a society to produce dozens of massive statues with such precise craftsmanship suggests a level of social organization and technical knowledge that may have been underestimated. Another unresolved question concerns the transportation and installation of the statues. Each limestone block likely weighed several hundred kilograms. Moving them from quarry sites to the burial complex would have required coordinated labor, sledges, rollers, or other mechanical solutions. Once at the site, the statues were erected upright near the tombs, possibly forming a ceremonial avenue or a guardian formation protecting the graves of elite warriors. The engineering involved in stabilizing these tall stone figures on uneven terrain further demonstrates the technical abilities of the Nuragic builders. Despite decades of research, the exact purpose of the statues remains debated. Some scholars believe they represent heroic ancestors or legendary warriors meant to guard the necropolis. Others suggest they symbolize divine protectors or mythological figures associated with Nuragic religion. Whatever their purpose, the statues clearly served as powerful visual symbols, towering above the landscape and announcing the presence of a sophisticated culture capable of monumental art. How do you think the craftsmen of the Nuragic civilization managed to carve such perfectly symmetrical circles into stone nearly 3,000 years ago? Share your thoughts or theories in the comments below. Perched impossibly on a sheer granite cliff in the eastern Himalayas, the legendary Taktsang Palphug Monastery, widely known as the Tiger's Nest, has long stood as one of the most extraordinary architectural feats ever attempted in a mountainous landscape. Suspended nearly 900 meters above the Paro Valley and positioned at an elevation of more than 3,100 meters above sea level, the monastery appears almost unreal when viewed from below. White temple walls cling to dark vertical rock faces, while golden roofs rise above drifting clouds, giving the illusion that the structure floats between earth and sky. While the monastery is revered as one of the most sacred sites of Himalayan Buddhism, it is also an engineering mystery that continues to puzzle historians, archaeologists, and structural engineers. The most profound question surrounding this monastery is not only why it was built in such an extreme location, but how builders centuries ago managed to transport enormous quantities of construction materials to a cliff that remains extremely difficult to reach even with modern infrastructure. The sacred significance of the site dates back to the 8th century, when the Buddhist master Padmasambhava, also known as Guru Rinpoche, is believed to have meditated in a cave within the cliff. According to Bhutanese tradition, he arrived on the back of a flying tigress and meditated for several months in what later became the central cave of the monastery. While the legend forms an essential part of Bhutanese cultural identity, archaeological studies indicate that the complex visible today was largely constructed in the late 17th century during the rule of the Bhutanese leader Ngawang Namgyal. Historical records describe the main monastery complex being established around the year 1692, though the cave shrines themselves likely existed earlier. Even acknowledging this relatively recent construction date by archaeological standards, the technical challenges of building the monastery remain staggering. Among all the mysteries surrounding the Tiger's Nest, the greatest challenge concerns the transport of construction materials to the cliff. Even today, visitors must hike for roughly 2 to 3 hours along a steep mountain trail before reaching the monastery. The path winds through pine forests and narrow ridges before finally approaching the cliff face where the temple complex stands. Despite improvements made in the 20th and 21st centuries, the route remains narrow and difficult. There is no road, no vehicle access, and no direct mechanical transport system reaching the monastery. This immediately raises a crucial historical question. How did builders in the 17th century move stone, timber, clay, metal ornaments, statues, and structural beams to such an inaccessible location? Architectural surveys indicate that the monastery complex consists of multiple temple buildings, corridors, staircases, and terraces built directly into the rock. Many sections incorporate heavy granite blocks extracted from the surrounding mountains. Some of these blocks weigh several hundred kilograms, while certain foundation stones are estimated to approach or exceed 1 metric ton. In addition, the buildings rely heavily on large beams of Himalayan cedar wood, a durable timber traditionally used in Bhutanese architecture. Transporting a single cedar beam weighing several hundred kilograms would already be difficult on flat terrain, yet the builders of Taktsang had to haul such materials up steep slopes and across narrow cliff edges. To understand the scale of the challenge, it is useful to compare the Tiger's Nest with other famous mountain constructions. For example, the Inca citadel of Machu Picchu was built at an elevation of roughly 2,400 meters, but it sits on a relatively broad mountain ridge that allowed the creation of terraces and transport paths. Similarly, medieval monasteries in the European Alps were usually constructed on plateaus or hilltops, accessible by mule trails. By contrast, Taktsang was built directly into a near-vertical rock face. In many places, the cliff angle approaches 80 degrees, meaning that there was almost no natural surface upon which heavy loads could be moved safely. Archaeological research conducted by Bhutanese authorities and international conservation teams in the late 20th century has attempted to identify possible construction techniques. Some historians suggest that builders may have used wooden scaffolding anchored into holes drilled into the rock face. Others believe that rope systems and primitive pulleys could have been used to hoist materials vertically. However, these hypotheses remain largely speculative because very little physical evidence of large-scale scaffolding has survived. Granite is extremely hard, and drilling deep anchor holes into such rock would have required advanced tools or immense labor. Yet clear traces of extensive anchoring systems are surprisingly limited. Another possibility is that some building materials were carved directly from the surrounding cliff itself. If masons extracted stone locally, rather than transporting it from distant quarries, This would have reduced the number of heavy blocks that needed to be hauled up the mountain. Even so, the construction still required huge quantities of wood, clay mortar, metal fittings, and decorative elements, none of which could have been sourced directly from the cliff face. These materials must have been carried upward by human labour or pack animals along narrow trails. Historical records from Bhutan describe the use of large labour forces organised by monastic authorities, suggesting that hundreds of workers may have been involved in transporting materials over extended periods of time. A particularly revealing moment in the modern history of the monastery occurred in 1998, when a devastating fire severely damaged several temple buildings. During the restoration process that followed, engineers and architects had to confront many of the same logistical challenges faced by the original builders. Helicopters were used to transport certain materials to the site, and even with modern technology, the reconstruction process was extremely complex and expensive. The restoration effort, completed in the early 2000s, demonstrated just how difficult it remains to move heavy materials to the monastery's precarious location. If helicopters were necessary in the modern era, it raises an even deeper mystery regarding how 17th century builders managed the task without such technology. The difficulty of transporting materials is further highlighted by the monastery's architectural precision. The buildings are carefully aligned along the cliff face, with terraces and staircases arranged so that the complex appears integrated with the natural rock formations. Structural analysis suggests that the builders distributed weight strategically across the cliff to prevent collapse, while wooden frameworks provide flexibility, allowing the structures to withstand earthquakes that frequently occur in the Himalayan region. This sophisticated integration of stone, wood, and natural rock implies a high level of engineering knowledge. Several exploratory surveys conducted by historians and conservation experts have also revealed that parts of the monastery extend into natural caves within the cliff. These caves likely served as meditation chambers long before the monastery complex was constructed. Accessing and expanding these caves would have required additional excavation work in extremely dangerous conditions. Yet despite the risks, builders managed to create corridors, staircases, and shrines that connect the caves with the outer temple structures. So how do you think ancient builders managed to transport tons of construction materials up a nearly vertical cliff to build the Taktsang Palphug monastery? Share your thoughts or theories in the comment section below. The Basseki statue base, discovered in northern Iraq in 1974 near the modern village of Basseki in the Dohuk region, is one of the most intriguing artifacts ever uncovered from the ancient world of Mesopotamia. At first glance, it appears to be a relatively modest object, a metal base that once supported a statue. Yet deeper scientific analysis has revealed that this artifact, dating to roughly the 23rd century BCE during the Akkadian Empire, preserves evidence of surprisingly advanced metallurgical technology. The base carries a long inscription dedicated to the Akkadian king Naram Sin, the grandson of the legendary ruler Sargon of Akkad, and it likely once supported a statue erected in honour of a deity or royal figure. But beyond its historical importance, the real mystery lies in how this object was manufactured. The Basseki statue base demonstrates a level of metalworking sophistication that appears unusually advanced for a civilization living more than 4,200 years ago, raising questions about how early Mesopotamian engineers mastered techniques that resemble much later metallurgical practices. Scientific studies conducted after the artifact was transferred to the Iraq Museum in Baghdad reveal that the base is not made from simple copper, which was the most common metal used in the early Bronze Age. Instead, the object consists of a carefully controlled bronze alloy containing copper, tin, and small quantities of lead. Modern laboratory analysis showed that the mixture is remarkably consistent throughout the object. suggesting that the metals were intentionally combined in precise proportions rather than accidentally mixed during smelting. This detail alone has fascinated archaeometallurgists. In the early 3rd millennium BCE, many regions of the world still relied on almost pure copper tools, and the production of bronze alloys required knowledge not only of metallurgy, but also of long-distance trade networks, since tin deposits were relatively rare in Mesopotamia. The nearest major sources of tin may have been located in regions as distant as Anatolia, Central Asia, or Iran, meaning that the raw materials used to create the Basseki statue base might have travelled hundreds or even thousands of kilometres before reaching an Akkadian workshop. Even more intriguing is the method by which the base itself was produced. The artefact appears to have been cast as a single piece of metal, rather than assembled from smaller components. The surface shows almost no visible seams or joints, which implies that ancient craftsmen used a highly sophisticated casting process. Many scholars believe that the object may have been produced using a technique similar to lost wax casting, a method in which a wax model is coated with clay to create a mould, the wax is melted away, and molten metal is poured into the cavity. This process allows extremely detailed shapes to be reproduced in metal, but it requires careful temperature control and an advanced understanding of how molten alloys behave. Evidence suggests that the Basseki base may have been created using such a process, which would mean that Akkadian metalworkers had mastered a technique that is often associated with later civilizations such as classical Greece or Imperial China. By comparison, some of the earliest large-scale bronze statues in Greece appeared more than 1,500 years later during the 1st millennium BCE. The physical quality of the metal also raises questions about ancient metallurgical knowledge. Researchers studying the artifact have noted that the bronze composition appears unusually stable, even after more than 4 millennia buried in the soil of northern Iraq. While some corrosion is visible, much of the structure remains remarkably intact, allowing the inscription to remain clearly legible. This durability may be partly explained by the specific ratio of metals used in the alloy, though even small amounts of tin can dramatically increase the hardness and strength of copper, while the addition of lead can improve the flow of molten metal during casting. The presence of these elements in the Basseki statue base suggests that Akkadian craftsmen were deliberately manipulating alloy properties in order to produce a metal object that was both structurally stable and capable of capturing fine details. One of the most remarkable features preserved on the surface of the base is its cuneiform inscription, consisting of approximately 23 lines of text. The inscription records that the statue was dedicated by King Naram Sin in honor of the goddess Ishtar, one of the most powerful deities in the Mesopotamian pantheon. The text also references the city of Akkad or Agadi, the legendary capital of the Akkadian Empire. Ironically, although this empire dominated much of Mesopotamia around 4,300 years ago, the precise location of its capital has never been definitively identified by archaeologists. The Basseki statue base therefore provides one of the rare surviving inscriptions directly mentioning the city, making the artifact extremely important for historians attempting to reconstruct the geography of the Akkadian state. Yet the inscription itself raises additional technical questions. The cuneiform signs carved into the bronze surface are unusually sharp and evenly spaced. Each wedge-shaped impression appears to have been carefully executed, maintaining consistent depth and alignment across the text. Creating such precise markings on hardened bronze would have been far more difficult than carving the same characters into clay tablets, which were the standard medium for Mesopotamian writing. Scholars continue to debate whether the inscription was engraved after the metal cooled, using specialized tools harder than bronze, or whether the characters were already present in the mold before the metal was cast. If the latter explanation is correct, it would imply that Akkadian craftsmen possessed the ability to design extremely detailed molds containing entire blocks of text, an achievement that would require remarkable planning and technical skill. Another mystery concerns the statue that once stood on top of the base. Several holes visible on the upper surface indicate that the base originally supported a separate metal figure that was attached using pins or rods. Unfortunately, the statue itself has never been found. Some archaeologists suspect that it was melted down in antiquity, perhaps during periods of political turmoil when valuable bronze objects were frequently recycled. If the statue was indeed made of bronze, it might have been significantly larger than the base itself, raising further questions about the scale of Akkadian metalworking capabilities. Large bronze sculptures require enormous quantities of molten metal and complex casting infrastructure, suggesting that specialized workshops existed within the Akkadian Empire. The discovery of the Basseki statue base also contributed to an unexpected archaeological breakthrough decades later. In the early 2000s, excavations at the nearby site of Basseki in Iraqi Kurdistan revealed the remains of a previously unknown ancient city dating to the Akkadian period. Archaeologists uncovered fortification walls, administrative buildings, and numerous clay tablets written in cuneiform script. These findings confirm that the region had been an important urban centre during the height of the Akkadian Empire, possibly serving as a northern administrative hub connecting Mesopotamia with trade routes leading toward Anatolia. The presence of the statue base in this region suggests that the monument may originally have stood within a major temple complex or ceremonial plaza associated with imperial authority. When viewed within the broader context of Bronze Age technology, the Basseki statue base highlights just how advanced ancient Mesopotamian engineering may have been. Around the same period, early Egyptian craftsmen were experimenting with copper tools, while many societies in Europe were still transitioning from stone to metal technology. Yet in the cities of the Akkadian Empire, artisans were apparently capable of producing carefully engineered bronze objects with complex inscriptions and durable alloy compositions. The artifact therefore challenges simplistic assumptions about technological progress in the ancient world, that rather than evolving slowly and uniformly, metallurgy appears to have advanced rapidly in certain early civilizations, driven by trade networks, skilled artisans, and centralized political power. If a civilization more than 4,000 years ago could produce such precise bronze technology, what do you think they truly knew about metallurgy? Share your thoughts in the comments below. Hidden beneath the dense tropical forests of southwestern Nigeria lies one of the most astonishing yet little-known engineering achievements of the ancient world, Sungbo's Eredo. Stretching across the landscape of Ogun State in a vast looping arc, this enormous earthwork system is widely believed to have been built by the ancestors of the Yoruba people sometime between the 8th and 10th centuries. At first glance, Sungbo's Eredo appears to be a simple earthen wall and ditch, yet archaeological investigations have revealed something far more extraordinary. The structure extends for roughly 160 kilometers, forming what is effectively one of the largest ancient man-made earthworks on Earth. In many sections, the ditch is between 10 and 15 meters deep, while the adjacent embankment rises as high as 20 meters above the surrounding terrain. When archaeologists began estimating the total volume of soil moved during construction, the numbers were staggering. Millions of cubic meters of laterite soil were excavated and piled into walls that still stand after more than 1,000 years. In terms of sheer labor, some researchers have suggested that the amount of earth moved rivals, or even exceeds the material displaced in the construction of several monumental stone pyramids in Egypt. Yet unlike pyramids built in open desert landscapes, Sungbo's Eredo was constructed in a humid rainforest environment, where erosion, vegetation, and heavy rainfall constantly threatened to destroy exposed earth structures. The first systematic archaeological attention towards Sungbo's Eredo began during surveys in the late 20th century, particularly through the work of British archaeologist Patrick Darling, who conducted extensive fieldwork in the 1990s. Darling's research revealed that the earthwork was not a random accumulation of soil, but a carefully planned engineering system. The structure consists of a deep outer ditch, from which soil was extracted and then piled inward to create a towering rampart. This configuration is typical of defensive earthworks, yet the scale here is extraordinary. In some places, the ditch walls are cut almost vertically into the laterite soil, suggesting the builders possessed highly efficient excavation techniques. Archaeologists studying the site have also observed that the earthwork follows a remarkably consistent design across vast distances, despite crossing hills, valleys, and dense forest. Maintaining such structural continuity across more than 100 kilometers implies a sophisticated understanding of large-scale planning and landscape management. However, the most intriguing and least understood aspect of Sungbo's Eredo lies in its earth excavation technology and long-term structural stability. The soil in this region is primarily laterite, a reddish, iron-rich earth that becomes extremely hard when exposed to air, but is relatively soft when freshly cut. Laterite can be shaped easily at first, yet it is highly vulnerable to erosion from tropical rainstorms. In southwestern Nigeria, an annual rainfall often exceeds 1,500 millimeters. Over centuries, such intense rainfall would normally erode earthworks rapidly. Yet large sections of Sungbo's Eredo remain clearly visible today, even after more than a millennium of weathering. This raises an important question. How did ancient builders manage to construct an earthen monument that could survive in such an aggressive climate? Some archaeologists believe the builders exploited the natural properties of laterite soil in a surprisingly advanced way. When freshly excavated laterite is compacted and exposed to air, it gradually hardens into a durable crust similar to weak stone. Evidence from certain sections of the ramparts suggests the soil was deliberately layered and compressed during construction, possibly using wooden tools or trampling techniques to compact each layer. Over time, the iron-rich minerals within the soil would oxidize and cement the structure together. This process may explain why the embankments remain structurally coherent even after centuries of rainfall and vegetation growth. In other words, the builders may have unknowingly applied a form of natural soil stabilization technology. Even more puzzling is the apparent control of drainage along the earthwork. Tropical rain typically causes erosion gullies to form quickly in earthen structures, yet many segments of Sungbo's Eredo show surprisingly limited erosion patterns. Some researchers have suggested that the builders intentionally designed the ditch and rampart geometry to redirect water flow away from the wall. The deep outer ditch may have acted not only as a defensive barrier, but also as a drainage channel that captured runoff during heavy rains. By guiding water into controlled pathways, the builders could have prevented destructive flooding from undermining the rampart. If this interpretation is correct, Sungbo's Eredo represents not merely a massive excavation project, but also an early example of environmental engineering. The labor required for such an undertaking would have been enormous. Estimates based on ditch dimensions suggest that constructing the full length of the earthwork may have required moving tens of millions of cubic meters of soil. If a single worker could excavate roughly 1 cubic meter of soil per day using simple tools, the total labor requirement might reach tens of millions of workdays. This implies the coordinated effort of thousands of workers over many years, perhaps organized under a powerful regional authority. Yet archaeological evidence for such a centralized state during the proposed construction period remains limited. This discrepancy between the scale of the project and the known political structures of the time continues to puzzle historians. Adding to the mystery is the cultural tradition surrounding the monument. Local Yoruba legends associate the structure with a powerful noble woman known as Bilikisu Sungbo, sometimes linked in folklore to the biblical Queen of Sheba. According to oral history, Sungbo was an extraordinarily wealthy ruler who commissioned the construction of the massive earthwork surrounding her domain. While historians treat this story cautiously, it highlights how deeply the monument is embedded in regional cultural memory. Today, Sungbo's Eredo stands as one of the most extraordinary examples of ancient landscape engineering in Africa. Despite its immense scale, it remains far less famous than other monumental structures such as the Great Wall of China or the defensive earthworks of medieval Europe. Yet in terms of raw size and the volume of earth moved, Sungbo's Eredo may rival many of these better-known constructions. Archaeological surveys, satellite imagery, and modern LiDAR mapping continue to reveal new sections hidden beneath vegetation, suggesting the monument may be even larger than originally believed. How did an ancient society more than 1,000 years ago build an earthwork this massive and make it survive in a tropical rainforest for centuries? Share your thoughts in the comments below. For decades, archaeologists believed that the earliest large urban centers in northern China were built mainly with rammed earth, a construction technique widely used by Neolithic cultures across the Yellow River basin. Yet the discovery of Shimao in the rugged hills of Shanxi province radically changed that understanding. Hidden for thousands of years and initially mistaken for a segment of the ancient frontier defences, later associated with the Great Wall of China, the ruins of Shimao have emerged as one of the most extraordinary archaeological discoveries of the 21st century. Dating to roughly 4,300 years ago, the site reveals a massive stone-built urban complex that flourished centuries before the earliest historically recorded Chinese dynasties. What makes this discovery particularly puzzling to researchers is not only the sheer scale of the city, but the unexpectedly advanced engineering knowledge required to build it. At its peak, Shimao covered approximately 400 hectares, making it one of the largest known urban settlements in East Asia during the late Neolithic period. Archaeological surveys conducted since the early 2000s, particularly those led by the Shanxi Provincial Institute of Archaeology beginning in 2011, have revealed a complex network of stone fortifications, terraces, palatial structures, and ceremonial areas distributed across the site. The most striking feature, however, is the city's extensive use of stone construction. In most other Chinese settlements from the same period, the builders relied heavily on compacted earth walls, a technology that required fewer specialized tools and could be constructed relatively quickly. Shimao, by contrast, employed enormous quantities of quarried stone, suggesting an architectural tradition that appears almost anomalous within the broader context of early Chinese civilization. The stone walls surrounding Shimao are monumental. Some sections stretch for several kilometers and reach heights of more than 6 meters, with thicknesses exceeding 2 meters in places. These fortifications were constructed from carefully cut stone blocks, fitted together with remarkable precision. The engineering challenge implied by such construction is significant. Transporting thousands of heavy stone blocks across uneven mountainous terrain would have required a highly organized labor force and logistical planning. Yet Shimao predates the widespread use of iron tools in China, leaving archaeologists puzzled about the methods used to quarry, shape, and move such massive materials. Comparisons are often drawn with later megalithic traditions around the world, such as the stone architecture of Machu Picchu or the monumental temples of Stonehenge, where large stones were also transported and precisely positioned. However, these structures belong to very different cultural contexts, and the emergence of similar stone engineering techniques in prehistoric northern China remains difficult to fully explain. Excavations have revealed that Shimao was not merely a fortified settlement, but a highly organized urban center with multiple defensive layers. Archaeologists have identified several concentric stone walls encircling different sectors of the city, indicating a sophisticated understanding of defensive architecture. Gate complexes with ramps, stairways, and narrow passages suggest that the entrances were deliberately designed to control movement and possibly to trap invading forces. Such defensive planning implies a level of military organization and strategic thinking that scholars previously believed developed much later in Chinese history. At the heart of the city lies an immense step structure, rising roughly 70 meters above the surrounding landscape, often described as a terraced pyramid. This monumental platform once supported palatial buildings and ceremonial spaces that likely served as the political and ritual center of Shimao. Excavations on the terraces have uncovered evidence of elite residences, storage facilities, and ritual areas, suggesting that the structure functioned as a combined administrative and religious complex. The scale of the platform has prompted comparisons with monumental constructions in other ancient civilizations, including the pyramid complexes of Teotihuacan, though Shimao appears to have developed independently within the cultural landscape of Neolithic China. Another puzzling feature of the site is the discovery of jade artifacts embedded within the stone walls themselves. And jade held immense symbolic significance in ancient Chinese culture and was typically associated with ritual authority, spiritual protection, and elite status. The intentional placement of jade blades and ornaments within the fortification walls suggests that the builders may have believed the stones possessed protective or sacred power. This practice has few clear parallels in other known Neolithic settlements of the region, raising questions about the religious beliefs and cosmological ideas held by the inhabitants of Shimao. Equally intriguing are the stone carvings found along certain sections of the walls. Archaeologists have documented reliefs depicting stylized human faces, animals, and geometric symbols carved directly into the stone blocks. Some of these images resemble ritual masks with large circular eyes and exaggerated features. Their artistic style differs noticeably from other contemporary Chinese traditions, leading some researchers to speculate that Shimao may have been influenced by cultural groups from the northern Eurasian steppe. If true, the site might represent a crossroads where different cultural traditions converged during the late Neolithic period. Human remains discovered near several gate complexes add yet another layer of mystery. Excavations uncovered clusters of skulls, many belonging to young women, buried near the city entrances. Some archaeologists interpret these findings as evidence of ritual sacrifice conducted during the construction or expansion of the fortifications. Similar practices have been documented in ancient societies across the world, where human offerings were believed to consecrate important architectural projects. However, the exact circumstances surrounding these burials remain unclear, and researchers continue to debate whether they represent sacrificial rituals, wartime casualties, or another form of ceremonial activity. Despite the remarkable scale and complexity of Shimao, the civilization responsible for building it appears to have vanished with little trace in later historical records. The city flourished around 4,300 years ago, but seems to have been abandoned several centuries later. Environmental changes, including increasing aridity in northern China, may have contributed to its decline. Another possibility is that shifting political power centers in the Yellow River Basin gradually drew populations away from the region. Whatever the cause, the disappearance of such a massive urban complex raises profound questions about the fragility of early civilizations. Today, Shimao Ancient City continues to challenge what we thought we knew about early Chinese civilization. Its age, massive scale, and advanced stone construction suggest that complex societies emerged much earlier than expected. Yet key questions remain unanswered. How such sophisticated building techniques developed so early, why jade was embedded in the walls, and what caused the city's sudden disappearance. As excavations continue, Shimao remains a powerful reminder that ancient civilizations may have been far more advanced than we imagine. What do you think is the most mysterious aspect of Shimao? Its advanced stone construction, the jade hidden within its walls, or the sudden disappearance of its civilization? Share your thoughts in the comments below. The Jiaohe ruins in northwestern China represent one of the most unusual and technically intriguing ancient cities ever discovered along the historic Silk Road. Located near the modern city of Turpan in Xinjiang, the ruins sit on a narrow natural plateau formed between two ancient river valleys. The plateau itself stretches roughly 1.7 kilometers in length and about 300 meters in width, creating what appears from the air like a natural island rising from the desert floor. Archaeological evidence suggests that the city was first established more than 2,000 years ago, possibly during the period of the early Cheshi Kingdom, and later flourished as an important administrative and trade center linking China with Central Asia. Yet what makes Jiaohe truly extraordinary is not only its age or its strategic location, but the mysterious engineering methods that allowed an entire city built primarily from earth to survive for millennia in one of the harshest desert climates in Asia. Unlike most ancient cities that relied heavily on stone blocks or fired brick, Jiaohe was constructed largely from rammed earth and mud brick, materials that in most environments deteriorate rapidly. Normally, buildings made from mud brick begin to crumble after only a few centuries unless they are constantly maintained. Even many famous ancient earthen settlements across the Middle East and Central Asia have eroded into little more than low mounds. However, at Jiaohe the remains of streets, walls, temples and residential structures are still clearly visible today, with some walls standing 8 to 10 meters high, despite having been exposed to more than 2,000 years of wind, temperature fluctuations, and desert erosion. This durability has puzzled archaeologists for decades and has led researchers to closely study the construction techniques used by the city's ancient inhabitants. One explanation involves the unique soil composition of the Turpan Basin, where the ruins are located. Geological surveys have shown that the plateau is composed largely of compacted loess soil, a fine wind-blown sediment that can become extremely dense when compressed. When ancient builders shaped the structures of Jiaohe, they took advantage of this natural property by cutting directly into the plateau and then reinforcing the remaining sections with additional layers of rammed earth. In effect, the city was not simply built on the plateau, it was carved from the plateau itself, leaving thick earthen walls that were part of the original landform. This method created structural stability comparable to natural rock formations. Some archaeologists have noted that this technique resembles the rock-cut architecture of places such as Petra in Jordan or Lalibela in Ethiopia, where entire structures were carved from solid stone. Yet the remarkable difference is that Jiaohe achieved a similar architectural permanence using earth rather than rock, which makes its survival far more surprising. Another factor believed to contribute to the city's longevity is the sophisticated rammed earth construction method used by its builders. In rammed earth technology, layers of moist soil are compressed between wooden forms to create dents, these solid walls. Evidence from excavations conducted during the 20th and early 21st centuries shows that the walls at Jiaohe were compacted in repeated layers, each only a few centimeters thick, producing a density far greater than that of ordinary mud brick construction. Some samples analysed by Chinese archaeologists revealed compression levels approaching those of modern engineered earth structures. Researchers from Xinjiang Archaeological Institutes have also found traces of organic fibres such as straw or plant fragments mixed into the soil. These fibres likely acted as reinforcement, similar to the way modern builders add fibres to concrete to prevent cracking. However, The exact proportions of these mixtures remain uncertain, and scientists still debate whether additional natural binders were used. Comparisons with other ancient earthen cities make Jiaohe's durability even more striking. For example, many settlements built from mud brick in Mesopotamia, once among the largest cities in the world, have largely collapsed into indistinct archaeological mounds. Even the impressive mud brick citadels of Central Asia, such as those in Uzbekistan and Turkmenistan, have suffered significant erosion despite being younger than Jiaohe. Yet large portions of Jiaohe's streets, courtyards, temples and administrative halls remain recognizable today. Some archaeologists argue that the city's design may have intentionally minimized structural stress, because many buildings were carved downward into the plateau rather than stacked upward. The structures had low centers of gravity and thick earthen walls integrated with the surrounding land, reducing the risk of collapse. Excavations carried out since the 1950s have uncovered a surprisingly complex urban layout that further demonstrates the engineering knowledge of its builders. Archaeologists discovered a central administrative district, residential quarters, storage facilities, and Buddhist monasteries arranged along a carefully planned network of streets. Some of the main streets measure 6 to 8 meters wide, indicating that the city once supported significant traffic and trade. The organization of these streets suggests deliberate urban planning rather than organic growth, which is remarkable given the constraints of the narrow plateau. Surveys conducted with aerial photography and satellite imagery in recent decades have revealed that many of the streets run in long, nearly straight lines across the plateau, reinforcing the idea that the builders possessed advanced surveying techniques for their time. The religious architecture of Jiaohe also illustrates the unusual construction methods used in the city. Several Buddhist stupas and monastery complexes were created by removing earth around a central core, leaving behind massive earthen towers that served as sacred structures. This approach resembles the sculpting of monumental stone temples in other parts of the world, yet at Jiaohe it was achieved using compacted earth. The survival of these structures raises further questions about how ancient builders prevented erosion and structural collapse. Some researchers suggest that the extremely dry climate of the Turpan Basin, where annual rainfall is extremely low, were helped preserve the buildings by limiting water damage. Still, even in such climates, earthen architecture typically requires maintenance, which means the long-term preservation of Jiaohe's structures may also reflect the extraordinary effectiveness of its construction techniques. Modern archaeological studies continue to investigate these mysteries. In the early 21st century, conservation teams conducted detailed structural analyses and soil sampling across the site. Their findings confirmed that certain walls retained densities and compressive strengths far higher than those found in typical historical earthen architecture. These results support the theory that Jiaohe's builders possessed a sophisticated understanding of how to manipulate local materials to achieve structural durability. Yet despite decades of research, scholars still cannot fully explain how the ancient inhabitants achieved such consistent quality across an entire city. The Jiaohe ruins reveal how ancient builders adapted to a harsh desert environment using simple materials. Despite being made mainly from earth, the city's walls, streets, and temples have survived for thousands of years. This remarkable durability continues to challenge modern understanding of ancient construction techniques. Could ancient engineers have possessed construction knowledge that modern science still doesn't fully understand? What is your theory about the mystery of Jiaohe? Share it in the comments below. Rising above the rugged ridges of the Rhodope Mountains in southern Bulgaria, the ancient rock city of Perperikon stands as one of the most enigmatic archaeological sites in southeastern Europe. Perched roughly 470 meters above sea level, this vast complex of temples, halls, stairways, and fortifications carved directly into the bedrock has puzzled historians and archaeologists for decades. Evidence suggests that human activity at the site began as early as the late Neolithic period, possibly around the 5th millennium BCE, making it older than many famous sacred centres of the Mediterranean world. Over thousands of years, the location evolved into a major spiritual and political hub, especially during the era of the Thracians, an ancient Indo-European people who inhabited large parts of the Balkans long before the rise of classical Greece and Rome. Yet what makes Perperikon particularly fascinating is not only its age or religious significance, but the astonishing engineering effort required to shape an entire mountain summit into a functioning urban and ceremonial complex. Excavations carried out since the early 21st century, particularly under the leadership of Bulgarian archaeologist Nikolai Ovcharov, have revealed a sprawling stone city covering more than 10,000 square meters. Within this area, researchers have uncovered a labyrinth of rock-cut chambers, ceremonial courtyards, massive staircases, drainage channels, and what appears to be a palace complex overlooking the surrounding valley. The site also includes remnants of fortification walls built during later historical periods, when Roman and Byzantine authorities occupied the region. However, the core of Perperikon is far older and far more mysterious, an intricate sacred precinct carved directly from the natural stone of the mountain itself. At the centre lies a large circular altar believed to have been associated with the cult of Dionysus, the Thracian Greek god of wine, ecstasy, and prophecy. Ancient writers described an oracle of Dionysus somewhere in the Rhodope Mountains that rivaled the prestige of the famous sanctuary at Oracle of Delphi. Some historians even speculate that Alexander the Great may have consulted such an oracle before launching his campaigns into Asia, though definitive proof remains elusive. Despite these historical references, the most perplexing aspect of Perperikon is the technology required to construct it. Unlike many ancient cities built by stacking quarried blocks, much of Perperikon was created by cutting directly into solid rock. Thousands of tons of stone were removed to form rooms, corridors, altars, and staircases, producing a multi-level complex that climbs up the natural contours of the mountain. Archaeologists have documented hundreds of carved steps, many of which maintain remarkably consistent dimensions despite the uneven terrain. Some of the chambers exhibit walls that appear surprisingly smooth and vertical, suggesting a level of control and planning that challenges assumptions about prehistoric stoneworking techniques in the region. The stone itself, primarily volcanic tuff and other hard rock formations typical of the Rhodope Mountains, is significantly more resistant to carving than softer materials like sandstone. This raises a critical question that researchers still struggle to answer. How did ancient builders achieve such large-scale stone shaping, using the limited tools believed to have been available during the Bronze Age? Metal tools existed, but their durability and hardness would have been far lower than modern steel implements. Experimental archaeology shows that shaping even a small cavity in similar rock using bronze chisels can take hours or even days of labour. Scaling that process to the immense size of Perperikon implies an extraordinary investment of time, manpower, and technical organisation. Some scholars propose that builders may have used thermal shock techniques, heating the rock with fire and then rapidly cooling it with water to cause cracking before chiselling away fragments. Others suggest that teams of workers using hammer stones and metal chisels gradually expanded the chambers over generations. Yet none of these explanations fully account for the apparent precision seen in certain areas of the site. Comparisons with other rock-cut monuments only deepen the mystery. For instance, the famous Nabatean city of Petra was carved largely into relatively soft sandstone cliffs, making it easier to sculpt elaborate facades. In contrast, the stone at Perperikon is harder and less uniform, meaning that the same techniques would have required far greater effort. Similarly, The temples carved into volcanic rock at Ellora Caves demonstrate remarkable engineering skill, and yet those monuments date many centuries later and were created with more advanced iron tools. If the earliest phases of Perperikon truly date back to the late Neolithic or early Bronze Age, the technological gap becomes even more striking. Archaeological investigations over the past 2 decades have uncovered further clues that complicate the story. Excavations have revealed layers of occupation from several historical periods, including Thracian, Roman, Byzantine, and medieval Bulgarian phases. Pottery fragments, coins, and inscriptions discovered throughout the site show that Perperikon remained active for centuries as a strategic fortress and religious centre. During Roman rule, the complex was expanded with additional structures and fortifications, while Byzantine engineers reinforced the defensive walls. Yet many of the core rock-cut features appear to predate these later modifications, suggesting that the original sacred complex was already ancient when later civilizations arrived. Radiocarbon dating of nearby habitation layers and artifacts supports the idea that ritual activity occurred here more than 3,000 years ago. One of the most intriguing discoveries concerns the elaborate system of channels carved into the stone near the central altar. These narrow grooves appear designed to guide liquids across the surface of the rock, possibly related to sacrificial rituals in which wine, oil, or animal blood flowed from the altar during ceremonies. The precision of these channels indicates deliberate engineering rather than random erosion. Yet the exact ritual function remains uncertain. Some researchers believe the flow of liquid may have been interpreted as a form of divination, with priests reading patterns or movements as signs from the gods. If this interpretation is correct, then the stone-cut infrastructure of Perperikon served not only architectural purposes, but also complex ceremonial and symbolic roles. Modern laser scanning and geological surveys have begun to map the entire site in unprecedented detail, revealing that the carved features form a carefully organized layout aligned with the natural topography of the mountain. Staircases connect multiple terraces, leading from lower habitation areas up to the elevated sacred zone at the summit. This hierarchical arrangement suggests a deliberate architectural plan, perhaps reflecting the spiritual cosmology of the Thracian people. Yet even with modern technology, archaeologists still debate how such a plan could have been executed in an era lacking advanced surveying instruments. Maintaining consistent angles, levels, and pathways across a rugged rocky peak would have required remarkable spatial awareness and coordination. In the end, Perperikon remains a monument that blurs the boundary between archaeology and mystery. It is simultaneously a religious sanctuary, a fortress, a city, and a colossal stone sculpture carved into the living mountain. The site testifies to the ingenuity of ancient builders who transformed raw geology into a sacred landscape that endured for millennia. Yet the deeper question remains unresolved. What combination of tools, knowledge, and organization allowed these early societies to reshape an entire mountaintop with such ambition and precision? Until new evidence emerges, the stone surfaces of Perperikon continue to preserve silent traces of a technological tradition that modern researchers can observe but still struggle to fully understand. What do you think ancient builders actually used to carve an entire mountain like Perperikon? Simple tools, lost technology, or something we still don't understand? Let me know your thoughts in the comments below. Beneath the desert sands of ancient Egypt lies a place that has long unsettled archaeologists, engineers, and historians alike. Hidden deep within the vast necropolis of Saqqara, not far from the ruins of the ancient capital Memphis, the underground complex known as the Serapeum of Saqqara represents one of the most puzzling feats of stone engineering from the ancient world. First brought to modern attention in 1850 by the French Egyptologist Auguste Mariette, The site initially appeared to be little more than a buried ceremonial passage. Yet as excavations continued, Mariette revealed something extraordinary. A vast subterranean network of tunnels stretching for nearly 3 kilometers, lined with massive chambers that house gigantic stone sarcophagi, carved from single blocks of granite and diorite. Yes, each box weighs between 70 and 100 tons, with the lids alone sometimes exceeding 30 tons. Even in an age of cranes and heavy machinery, moving such objects would be a considerable challenge. The fact that these structures were created and placed underground more than 3,000 years ago has raised questions that remain difficult to answer. According to the traditional interpretation, the Serapeum served as the burial place for the sacred Apis bulls associated with the ancient Egyptian deity Apis. These bulls were considered living manifestations of divine power and were mummified with elaborate rituals upon their death. However, the enormous stone containers discovered in the tunnels have puzzled researchers for decades. Each granite sarcophagus measures roughly 3.8 meters in length, more than 2 meters in height, and weighs far more than would be necessary to contain the remains of a single animal. Some of the sarcophagi discovered during early excavations were completely empty, while others contained only fragments of animal bones that appeared broken or disturbed. These inconsistencies have fueled debate about whether the structures served purely ritual purposes or whether they held additional functions that remain unknown. Yet beyond their purpose, it is the extraordinary precision of the stonework that has generated the greatest scientific curiosity. Granite is an extremely hard material, measuring approximately 6 to 7 on the Mohs hardness scale. Even modern stoneworkers require diamond-tipped tools and powerful machinery to cut and polish granite efficiently. Despite this, the surfaces of the Serapeum sarcophagi are remarkably smooth and geometrically precise. Many interior walls appear polished to a mirror-like finish, and the corners form near-perfect right angles. Engineers who have examined the boxes have noted that the flatness of certain surfaces deviates by only fractions of a millimeter across several meters. For comparison, achieving such tolerances in modern manufacturing often requires precision milling machines or industrial grinding tools. Among the most intriguing aspects of the Serapeum is the evidence suggesting sophisticated drilling and cutting techniques. During detailed studies of Egyptian stoneworking in the 19th century, the renowned archaeologist Flinders Petrie carefully examined drill holes and tool marks from multiple ancient sites, including Saqqara, and Petrie observed spiral grooves inside cylindrical holes drilled into hard stone such as granite and diorite. These grooves appeared remarkably regular, indicating a rotational drilling process rather than simple hammering or chiseling. Based on measurements of the groove's spacing, Petrie concluded that the cutting tools seemed to advance through granite at a rate that was surprisingly fast. Far faster than expected if the tools were made only of copper, the material traditionally attributed to ancient Egyptian drills. Experimental archaeology has attempted to reproduce these marks using copper tubes combined with abrasive sand, which is the conventional explanation proposed by Egyptologists. While such techniques can indeed drill into granite, the process is extremely slow and often produces irregular patterns. In contrast, some drill holes observed on ancient artifacts display extremely clean and uniform spiral traces. Petrie famously remarked that the precision suggested a degree of mechanical efficiency, not usually associated with tools made from soft metals. This observation does not necessarily imply lost advanced technology, but it does suggest that the ancient craftsmen may have employed drilling methods far more refined than previously assumed. The mystery deepens when one considers the scale of the Serapeum project. Granite blocks used for the sarcophagi were likely quarried in the region of Aswan, located more than 800 kilometers south of Saqqara along the Nile River. Transporting stones weighing up to 100 tons would have required enormous logistical coordination. Once the blocks reached Saqqara, They had to be carved with extreme precision and then lowered into narrow underground corridors where the chambers were located. Some passageways are only slightly wider than the sarcophagi themselves, leaving little margin for error during installation. Modern engineers examining the site often remark that placing such massive objects in confined subterranean spaces would be difficult even with contemporary equipment. Excavations throughout the 20th century continued to uncover additional details about the complex. Archaeological investigations during the 1960s and 1970s documented the architectural layout of the tunnels, revealing that the main gallery branches into several chambers arranged in a symmetrical pattern. Each chamber houses one of the monumental granite boxes. The tunnels themselves are carved directly into limestone bedrock, with ceilings and walls showing surprisingly straight lines and smooth surfaces. Although chisel marks are visible in some sections, other areas appear unusually uniform, suggesting that the excavation may have involved systematic and carefully planned methods. Researchers have compared the engineering of the Serapeum with other achievements of ancient Egypt, such as the precise stone joints found in the Great Pyramid of Giza. While the pyramids demonstrate remarkable architectural alignment and large-scale construction, the Serapeum reveals something different: the ability to shape enormous blocks of extremely hard stone with extraordinary accuracy. In many respects, the site resembles a gigantic underground gallery of precision-carved granite containers. Yet some scholars have even described it as one of the most technically impressive stoneworking achievements of the ancient world. Despite more than a century and a half of study, several questions remain unresolved. Exactly how the ancient craftsmen drilled, cut and polished granite with such precision continues to be debated. No advanced drilling devices have been discovered in the archaeological record, and the surviving tools found in Egyptian workshops are primarily made from copper and stone. Yet the physical evidence preserved on the sarcophagi and other artifacts indicates that the techniques used were highly effective, whether through ingenious combinations of abrasives, carefully engineered drilling systems, or methods that have yet to be fully reconstructed. The builders of the Serapeum achieved results that still challenge modern understanding. What do you think? Were these incredible feats the result of lost advanced techniques, or simply human ingenuity pushed to its absolute limits? Share your thoughts in the comments below. Pukara de Quitor Cliff Fortress is one of the most impressive ancient cliff fortresses along the edge of the Atacama Desert, where wind, sun, and unforgiving terrain together create an environment seemingly impossible for a large-scale defensive structure to exist. Yet the ancient Atacameño people built here a complex system of fortifications so sophisticated that even today archaeologists, architects, and engineers remain astonished by their boldness. The entire stronghold clings to the mountainside, rising in multiple tiers that blend natural landforms with remarkable material craftsmanship. What surprises researchers most is the dry stone walling technique, in which stones are fitted so tightly without mortar that the structure has survived for centuries in a place where even the smallest error could have caused collapse. The fortress walls resemble lines etched into the mountainside, assembled from countless stones of different sizes locked together so precisely that gaps are nearly non-existent. From afar, the walls merge into the desert hillside. Up close, one can see the meticulous selection, shaping, rotation and placement of each stone to self-lock and distribute pressure evenly throughout the structure. There is no trace of mortar, no artificial binding agent, only weight, shape, and the impeccable calculations of ancient builders. Many wall segments lie on steep slopes where transporting material is a challenge even today. Yet the ancestors of Atacama not only moved the stones, but arranged them into formations as solid as modern defensive works, resisting powerful winds, landslides, and geological shifts for hundreds of years. This raises a profound question. How much did they understand about geology and gravity? Did they possess experimental methods, measurement techniques, or inherited knowledge that remains undiscovered today? While major civilizations such as the Inca or Tiwanaku are known for refined stonemasonry, Pukara de Quitor displays a very different stylistic identity. The stones were not polished smooth, but left partially natural, enhancing their ability to grip one another. Even so, the level of tightness between layers is astonishing. Some researchers propose that the builders used a technique based on splitting the stones along natural grain lines so they would interlock with bedrock behind them, forming an exterior wall that acted almost like a protective shell. This also helped the walls absorb impact from ancient weapons or mild seismic activity common in the Andes. Some theories suggest the Atacama people experimented with many arrangements before achieving the optimal configuration, yet archaeological evidence does not show a clear trial and error process. Instead, even the oldest wall sections exhibit extraordinary mastery, implying that the builders inherited a highly developed architectural tradition predating the fortress itself. The origin of this knowledge remains mysterious. Was it self-developed or influenced by unknown groups who once passed through the harsh desert region? The dry stone technique raises another question. How do these walls resist sand abrasion or gradual displacement? The Atacama Desert is one of the driest places on Earth, because yet strong winds are capable of eroding rock surfaces over decades. Even so, the walls of Pukara de Quitor remain stable. Geologists believe the builders selected dense, durable stones that resist weathering, though exactly how they transported and sorted these stones remains unclear. Some theories suggest the stones were quarried directly on the slope, using gravity to move them downward before guiding and locking them into place. This method would have been extremely risky, requiring precise coordination, but it fits well with what is known about Atacameño society. The ingenuity of the walls becomes even clearer when seen in the context of the steep cliffs they occupy. Many fortified positions sit on inclines difficult to reach, yet the stonework there is highly stable. Some walls were reinforced by anchoring them to natural bedrock, forming a seamless bond between human construction and the mountain itself. The fortress becomes not merely a structure on rock, but a structure with the rock, an architectural philosophy showing adaptation rather than resistance to nature. Geotechnical analysis reveals that the arrangement of stones disperses load effects rather than concentrating stress in a single point. This demonstrates a sophisticated understanding of gravity and structural stability, on par with major ancient civilizations. The stone walls not only served as defenses, but also defined internal functional zones such as living areas, lookout points, storage spaces, and narrow passages designed to control movement during conflict. These internal partitions were built using the same dry stone method, simple, rugged, yet extremely durable. Their arrangement in tight spaces shows an advanced understanding of spatial optimization and safety. Some lower walls may have served ritual functions or supported perishable structures that no longer survive. Whatever their purpose, the consistency of stone-fitting techniques is undeniable. Encircling the fortress are long defensive walls that follow the mountain's natural contours. Their height varies depending on terrain irregularities. Remarkably, these walls run smoothly along slopes without abrupt breaks, proving that the builders surveyed the land with great precision. They did not merely stack stones, they aligned the entire architectural plan with natural wind patterns and the shape of the ridge, and this gave the fortress an unexpected harmony with nature, rare in ancient military architecture. The perfection of the dry stone method has sparked debates. Did the Atacameño people possess higher engineering capabilities than previously assumed? Did they use specialized tools, measurement systems, or stone selection techniques that modern researchers have yet to reconstruct? Some scholars argue that a non-written system of technical knowledge, rules, practices, and hands-on experience was transmitted across generations of builders. Coupled with the fortress' history of violent conflicts, particularly against Spanish forces in the 16th century, the durability of these walls becomes even more extraordinary. They survive not only time, but the assaults of human warfare. Thus, the dry stone walls of Pukara de Quitor are more than a construction technique. They're a symbol of ancient knowledge, reflecting the precision and insight of a community thriving in one of the harshest environments on Earth. From stone selection, fitting methods, load optimization, and terrain integration to anticipating natural erosion, all these elements form a mystery not yet fully explained. Pukara de Quitor Cliff Fortress is not merely a fortress. It is a testament to the capabilities of past civilizations, a chapter of stone architecture still unread in its entirety. Until its secrets are fully uncovered, these tightly fitted walls will continue standing silently in the desert, challenging modern assumptions about ancient engineering and craftsmanship. Do you think the dry stone construction technique of Pukara de Quitor suggests that ancient builders possess knowledge far more advanced than we once believed? Share your thoughts in the comments below. High in the rugged highlands of West Java, Indonesia, the mysterious terraces of Gunung Padang rise above the surrounding jungle, like the remnants of an ancient monument forgotten by time. At first glance, the site appears to be a series of stone platforms built along the slope of a volcanic hill, but closer inspection reveals something far more remarkable: an enormous complex of carefully arranged basalt columns forming geometric terraces that stretch across the summit. For decades, archaeologists considered Gunung Padang a typical Southeast Asian megalithic site, likely built around 2,000 years ago. However, modern surveys, excavations, and geological studies have revealed layers of complexity beneath the surface, raising profound questions about the true age, construction techniques, and purpose of this enigmatic structure. Among all its mysteries, the most striking is the astonishing geometry and engineering precision of its massive stone terraces, an architectural feat that continues to challenge conventional explanations. The visible portion of Gunung Padang consists of 5 large terraces arranged step-like along the hillside, connected by stone stairways that climb steadily toward the summit. These terraces collectively cover an area of roughly 3 hectares, making Gunung Padang one of the largest megalithic sites in Southeast Asia. Each terrace is built using thousands of naturally hexagonal basalt columns, a volcanic rock that forms when cooling lava fractures into long polygonal pillars. Individual columns at the site often measure between 1 and 2 meters in length and can weigh several hundred kilograms. What makes Gunung Padang extraordinary is not merely the presence of these stones, but the way they have been deliberately organized. Many columns are placed horizontally to form retaining walls, others are laid flat to create floors, while some are stacked vertically to build structural boundaries. The result is a series of platforms with clearly defined geometric layouts, rectangular courtyards, straight alignments, and carefully stabilized walls that demonstrate a surprising level of architectural planning. Such geometric order is difficult to dismiss as accidental. In several areas, the alignment of stone walls approaches near-perfect linearity, suggesting that the builders used deliberate surveying techniques. Archaeologists have noted that some terrace edges maintain straight lines extending for tens of meters, an impressive achievement considering the irregular shapes of the basalt columns. When compared with other prehistoric stone monuments around the world, Gunung Padang stands out for the sheer scale of its columnar construction. For instance, the famous standing stones of Stonehenge were erected using large monolithic blocks transported over long distances. Yet the arrangement at Gunung Padang involves thousands of smaller but extremely dense volcanic columns placed with remarkable structural logic. Similarly, the megalithic city of Nan Madol uses stacked basalt prisms to create massive walls and canals, but even there, the construction is largely horizontal. At Gunung Padang, by contrast, the builders appear to have experimented with multiple orientations, horizontal, vertical, and angled placements, creating terraces capable of stabilizing the steep volcanic slope. The logistical challenge alone would have been immense. The summit of Gunung Padang sits roughly 880 meters above sea level, and the steep hillside makes transportation extremely difficult even with modern equipment. Moving hundreds or thousands of basalt columns, each weighing between 200 and 600 kilograms, would have required coordinated labor, advanced knowledge of balance and slope stabilization, and a sophisticated understanding of stone placement. Some researchers estimate that constructing the visible terraces could have required the movement of tens of thousands of individual stone columns. Without metal tools, wheeled vehicles, or modern engineering machinery, the ancient builders must have relied on careful planning and communal labor to achieve this feat. Archaeological investigations have gradually uncovered more details about how these terraces were constructed and modified over time. Early documentation of the site dates back to Dutch colonial researchers in the late 19th century, but systematic archaeological work began in the 20th century. Excavations in the 1970s confirmed that the upper terraces were human-made structures, likely used for ceremonial purposes. Radiocarbon dating of organic materials found within the upper layers suggested an age of roughly 2,000 to 2,500 years. At that time, Gunung Padang was interpreted as a megalithic ritual complex similar to other stone monuments across Indonesia. However, new discoveries in the 21st century dramatically complicated this interpretation. Between 2011 and 2014, interdisciplinary research teams conducted geophysical surveys using ground-penetrating radar, seismic tomography, and electrical resistivity measurements. These studies suggested that the visible terraces might represent only the outermost layer of a far larger structure hidden beneath the hill. According to some interpretations of the data, the hill may contain several distinct layers of construction extending deep underground. The uppermost terrace complex appears to sit on a layer of packed stones and soil, beneath which lies another arrangement of columnar basalt that may represent an earlier phase of construction. Some preliminary analyses even propose that deeper layers could be several thousand years older than the visible terraces. If these interpretations are correct, Gunung Padang could represent a multi-phase monument built and rebuilt over many generations. Such a scenario would make it somewhat comparable to the step pyramids of ancient civilizations, where successive cultures expanded earlier foundations into larger monuments. For example, the earliest Egyptian pyramid, the Step Pyramid of Djoser, evolved through multiple construction stages before reaching its final form. At Gunung Padang, a similar process may have occurred, with later builders modifying and expanding older stone structures on the volcanic hill. Yet the possibility that Gunung Padang contains extremely ancient layers remains controversial, and some researchers have suggested that certain deep samples might indicate construction activity more than 10,000 years ago, potentially predating the earliest known monumental architecture anywhere on Earth. If proven true, such a finding would challenge long-standing assumptions about the development of complex societies. However, many archaeologists remain skeptical, arguing that some of the deeper formations could simply be natural volcanic deposits rather than human-made structures. Distinguishing between natural geological formations and intentional construction is a difficult task, especially in a region shaped by volcanic activity. Despite these debates, few scientists dispute the remarkable engineering visible in the terraces themselves. The careful placement of basalt columns demonstrates a clear understanding of weight distribution and slope reinforcement. In many places, the columns are arranged in interlocking patterns that help stabilize the terraces against erosion and landslides. This technique resembles dry stone construction methods used by ancient civilizations such as the Inca, whose fortress at Sacsayhuaman features massive stone blocks fitted together so tightly that no mortar is required. While the stones at Gunung Padang are smaller, the principle of structural stability through precise placement appears strikingly similar. Today, Gunung Padang remains one of the most intriguing archaeological sites in Asia. Its massive terraces, built from thousands of volcanic columns, display an unexpected level of geometric organization and engineering skill. Whether the site is merely a sophisticated ritual complex from the late prehistoric period, or the outer layer of a much older hidden structure, remains an open question. Continued excavation and scientific analysis may eventually reveal the true story behind these enigmatic terraces. Until then, the silent basalt columns of Gunung Padang stand as a powerful reminder that the technological capabilities of ancient societies may have been far more advanced and far more mysterious than we once believed. The La Almoloya Palace complex, nestled in the rugged hills of southeastern Spain, stands as one of the most extraordinary archaeological discoveries associated with the El Agar civilization of the Bronze Age, dating back roughly between 2200 and 1550 BCE. At first glance, it may appear as just another ancient settlement reduced to stone foundations and fragmented walls, yet beneath its weathered surface lies compelling evidence of a society that was far more sophisticated, organized, and technologically capable than previously imagined for its time. What distinguishes La Almoloya from countless other prehistoric sites is not merely its age or its artifacts, but the unmistakable impression that its builders possessed a deep understanding of architecture, engineering, and spatial planning, knowledge that seems strikingly advanced, almost anachronistic when compared to other contemporary cultures across Europe. As archaeologists began to uncover its structures layer by layer, a new narrative emerged, one that challenges long-held assumptions about the limits of Bronze Age societies and forces us to reconsider how early complex systems of governance, construction, and social organization truly developed. At the heart of this complex lies a large rectangular hall, often interpreted as a form of early political assembly space, complete with stone benches arranged along the walls and a central open area that could accommodate dozens of individuals. While this alone is remarkable, it is the architectural precision and planning behind such a structure that truly demands attention. The hall was not randomly constructed. Rather, it reflects a deliberate design in which proportions, symmetry, and functionality were carefully balanced. The walls were built using well-selected stones, fitted together with a level of consistency that suggests standardized construction methods rather than improvised building. Even more striking is the evidence that these structures were part of multi-level constructions, indicating that the inhabitants of La Almoloya were capable of creating buildings with vertical complexity, an achievement that requires not only technical skill, but also an understanding of load distribution, structural stability, and material limitations. Such knowledge is not typically associated with societies of this era, raising questions about how it was acquired and transmitted. Perhaps the most fascinating aspect of La Almoloya lies in its sophisticated approach to urban planning and infrastructure, particularly its drainage and water management systems. Archaeological findings reveal that the settlement was equipped with carefully designed channels and drainage paths, allowing water to be directed away from living spaces and communal areas. This suggests that the builders were acutely aware of environmental challenges such as rainfall and erosion, and had developed effective strategies to mitigate their impact. The presence of such systems implies a level of foresight and planning that goes far beyond basic survival, pointing instead to a community that prioritized durability, hygiene, and long-term sustainability. It is difficult to reconcile this level of engineering with the conventional image of Bronze Age settlements as relatively simple and rudimentary. Instead, La Almoloya appears as a site where architecture and environment were integrated into a coherent and functional whole. Equally intriguing is the apparent standardization in construction techniques observed across different parts of the complex. Walls, floors, and structural elements exhibit consistent patterns in size, alignment, and composition, suggesting that the builders followed established guidelines or shared knowledge systems. This raises the possibility that specialized labor roles existed within the society, including skilled builders or architects who possessed advanced technical expertise. The coordination required to construct such a complex would have necessitated not only individual skill, but also collective organization, resource management, and possibly centralized authority to oversee large-scale building efforts. In this sense, the architecture of La Almoloya becomes a reflection of its social structure, revealing a community capable of mobilizing labor and knowledge in a highly efficient and controlled manner. The use of materials further underscores the advanced nature of construction at La Almoloya. Stones were not simply gathered and stacked. They were selected, shaped, and positioned with clear intent. Floors were often reinforced, and certain areas show signs of deliberate leveling, indicating that the builders took great care to create stable and even surfaces. The durability of these structures, many of which have survived in recognizable form for thousands of years, speaks to the effectiveness of their methods. It is worth considering that these techniques were developed without the aid of metal tools as advanced as those found in later periods, making their achievements even more remarkable. How did they achieve such precision with the limited technology available to them? This question remains one of the central mysteries surrounding the site. Beneath the surface of these architectural achievements lies an even deeper enigma: the apparent disappearance of such advanced construction knowledge following the decline of the El Argar civilization. Around 1550 BCE, the culture that built La Almoloya seems to have collapsed or transformed abruptly, leaving behind little evidence of continuity in subsequent societies in the region. The techniques, planning strategies, and architectural sophistication evident at the site do not appear to have been directly inherited or replicated at the same level in later settlements. This raises a troubling possibility that a significant body of practical knowledge accumulated over generations was lost or abandoned. Whether this was due to environmental changes, social upheaval, resource depletion, or external pressures remains unclear, but the result is a historical gap that continues to puzzle researchers. Adding another layer to this mystery is the discovery of elite burials within the complex, including a particularly notable tomb located beneath the assembly hall. The placement of such a burial in a central and symbolically significant location suggests a close relationship between political power, social hierarchy, and architectural space. It is possible that the individuals interred there played a direct role in the planning or construction of the complex, or at the very least held authority over those who did. This connection between leadership and built environment further reinforces the idea that La Almoloya was not merely a settlement, but a carefully designed center of power, where architecture served both practical and symbolic functions. When viewed as a whole, the La Almoloya Palace complex challenges us to rethink what we believe about the capabilities of ancient societies. Its advanced construction techniques, integrated infrastructure, and organized layout point to a level of development that seems to anticipate later civilizations by centuries, if not millennia, Rather than fitting neatly into the established timeline of gradual technological progress, La Almoloya stands as an anomaly, a site that appears to leap ahead of its time, only to vanish without a clear legacy. It invites us to consider the possibility that human history is not a simple, linear progression, but a complex tapestry of advances, regressions, and lost knowledge. In the end, the true significance of La Almoloya may lie not only in what it reveals, but in what it conceals. Each stone, each wall, each carefully constructed space hints at a deeper understanding that we have yet to fully grasp. The builders of this complex were not merely surviving, they were innovating, organizing, and shaping their environment in ways that continue to surprise modern observers. Their achievements, preserved in the silent ruins of La Almoloya, stand as a testament to the ingenuity of a civilization that, despite its disappearance, still has much to teach us, if only we can learn how to read the clues it left behind. Do you think the advanced construction knowledge of La Almoloya was truly lost, or could it still be hidden somewhere, waiting to be rediscovered? Share your thoughts in the comments below. In the southeastern region of the Iberian Peninsula, where barren rocky mountains meet the seasonally dry Andarax River, the fortified complex of Los Millares has stood for more than 5 millennia as a silent remnant of an era when humans first began to organize complex societies, exploit metals, and, most importantly, construct defensive works far beyond what their age should have allowed. Upon its discovery, Los Millares shocked archaeologists not only because of its scale, but also because of a level of sophistication far exceeding what anyone believed an early Bronze Age community capable of achieving. 3 large defensive walls encircled the settlement, each equipped with watchtowers, deep ditches, and carefully placed gate systems intended to control the approach of any enemy. These were not temporary defensive barriers. They were symbols of prolonged anxiety, serious military preparedness, and a society accustomed to the constant threat of external attack. The stacked stone layers, the curved wall segments designed to create advantageous firing angles, and the watchtowers positioned at strategic points reveal that the inhabitants of Los Millares not only knew how to defend themselves, but also understood the art of warfare. Inside those walls, the lives of the Los Millares inhabitants emerge through traces of smelting furnaces, copper tools, clearly organised residential zones, and more than 80 dolmen tombs surrounding the settlement. Notably, these tombs were arranged according to specific rules, possibly linked to astronomical observation or religious rites. Yet this suggests that the community was not only advanced militarily, but also possessed a rich spiritual life and a complex belief system. The grave goods indicate a socially stratified community, where individuals of higher status were buried in larger, more elaborate tombs. However, despite signs of hierarchy, Los Millares left no evidence of a palace or any clearly defined centre of political authority. There is no walled-off area reserved for a single leader, nor any tomb overwhelmingly superior to others like the royal graves seen in other civilizations. This raises an intriguing question. Who commanded the construction of this entire fortress? A powerful chief, a council of elders, or a political structure entirely different from anything we know? Fair copper metallurgy was the defining factor that elevated Los Millares into an economic centre of the Iberian region. The smelting furnaces found here prove they mastered the techniques of extracting, heating, moulding, and casting copper. Copper artifacts in the Los Millares style have been found at distant sites, indicating a far-reaching trade network. This reinforces the idea that Los Millares was not merely a village, but a regional hub of economic, religious, and military influence. Yet this very wealth may have made it a target for surrounding communities, those seeking to seize its resources, technologies, and power. The discovery of numerous arrowheads, weapons, and burn marks on the walls indicates that the inhabitants had to defend themselves against repeated assaults. The construction of 3 walls was no accident. It was the accumulated response of many generations to dangers long forgotten by modern researchers. Yet amid all this prosperity and preparedness, what makes Los Millares one of Europe's greatest archaeological mysteries is how it vanished. Suddenly, quietly, and almost without leaving a trace of the real cause. Around 2300 BCE, this vast settlement was abandoned. There is no thick ash layer pointing to a catastrophic fire, no scattered bodies indicating a massacre, and no evidence of a large-scale epidemic. The inhabitants of Los Millares appear to have left in an orderly fashion, as though following a prearranged plan, taking what they needed and never returning. There are no signs of chaos, no hastily abandoned objects, no half-empty storage areas, no signs of despair. Their disappearance is calm to the point of being unsettling. Many hypotheses have been proposed, yet none sufficiently explain the mystery. The first suggests climate change. Iberia experienced a prolonged drought during that period, leaving the land barren, water scarce, and crops unproductive. This could have forced the inhabitants to migrate to more fertile areas. However, geological studies show that climate change did not occur suddenly enough to compel them to abandon such a major centre, and if climate truly were the cause, why did this resourceful and resilient community, one that had thrived for centuries, not attempt to adapt? The second hypothesis suggests copper depletion. If the main resource had run out, the economy of Los Millares would have collapsed. Yet modern geological surveys indicate that copper deposits still exist around the site. Moreover, this community already maintained an extensive trade network that would have allowed them to import metal if necessary. Thus, this explanation is also unconvincing. The third hypothesis concerns warfare. Perhaps they were not destroyed in a single battle, but worn down by prolonged pressure from newly emerging groups or more aggressive societies. These groups might have gradually weakened Los Millares, reducing manpower and undermining their ability to maintain large fortifications. But if warfare were truly the cause, why is there no clear evidence of destruction? Why did the inhabitants leave in order rather than die on sight or flee in panic? These unanswered questions leave the warfare hypothesis incomplete. The most debated hypothesis involves the rise of the El Agha culture, a powerful society with clear hierarchical structures and advanced metallurgical skills. El Agha emerged immediately after the disappearance of Los Millares, leading many scholars to believe that the inhabitants were absorbed into this new culture. Yet again, there is no direct evidence of conquest, no extensive destruction, no mass violence, and no abrupt architectural or material shift at Los Millares indicating El Agha occupation. If Los Millares people did join El Agha, then the process must have been gradual and peaceful, but this still does not explain why they abandoned an economic, religious, and military centre built over generations. What deepens the mystery is the complete absence of any evidence indicating that they built a new settlement elsewhere. No second Los Millares has been found, nor any clear migration trail. The community seems to have dissolved into space and time, leaving no direct descendants, no folklore, no cultural memory. The dolmen tombs fell out of use, the furnaces went cold, the walls remained standing, but no footsteps passed through them again. A once powerful, wealthy and complex society vanished into absolute silence. A silence so profound that many archaeologists believe we are still missing a crucial piece of the puzzle. More speculative theories suggest internal conflict, a shift in religious belief requiring abandonment of the old settlement, or even environmental disasters such as earthquakes or severe erosion. But all of these remain conjecture. No definitive evidence supports any of them. And it is precisely this void, where archaeological reasoning cannot reach, that makes Los Millares extraordinary. A massive fortress built against unseen enemies, a metallurgical centre of regional influence, a socially sophisticated and spiritually rich community, yet one that evaporated within a relatively short time, leaving behind only mute stone walls. Those walls reveal nothing of their final story. They stand, worn by wind and layered with centuries of dust, as though guarding a truth modern humans are not yet equipped to uncover. And until that missing piece is found, the sudden disappearance of Los Millares will remain one of the greatest unanswered questions in European archaeology. What do you think truly caused a powerful civilization like Los Millares to disappear completely without leaving a trace? Share your thoughts in the comments below. Rising from the arid hills of southeastern Spain, the Fuente Alamo stands as one of the most intriguing and underappreciated archaeological sites of prehistoric Europe. Belonging to the enigmatic El Agar culture, which flourished between roughly 2200 and 1550 BCE, this settlement reveals a society that was far more complex, organized, and technologically advanced than once believed. At first glance, Fuente Alamo may appear to be just another ancient hillside ruin, but beneath its layered terraces and stone walls lies a narrative of innovation, hierarchy, and mystery that continues to challenge modern understanding. The settlement itself is ingeniously constructed along a steep slope, with houses arranged in terraced formations that seem almost engineered with modern precision. These structures were built using carefully fitted stones, forming durable walls that have endured for millennia without the use of mortar. The layout suggests not only a keen understanding of architecture and environmental adaptation, but also a centralized planning system, an early form of urban organization that hints at a structured and possibly hierarchical society. Narrow pathways and controlled access points further imply that the settlement was designed with both efficiency and defense in mind, reinforcing the idea that Fuente Alamo may have functioned as both a residential center and a strategic stronghold. Yet, one of the most striking aspects of life at Fuente Alamo lies not in its architecture, but beneath it. The inhabitants practiced the unusual custom of burying their dead directly beneath the floors of their homes. These burials, often placed in ceramic jars or simple pits, were sometimes accompanied by grave goods such as weapons, ornaments, and tools. The variation in these offerings reveals a clear social stratification. Some individuals were interred with elaborate items, while others were buried with little to nothing. This stark contrast suggests the presence of a rigid class system, possibly governed by elites who controlled both resources and labor. It also raises profound questions about belief systems. Did the living see themselves as coexisting with their ancestors, or were these burials a symbolic claim over property and lineage? However, the most compelling and mysterious feature of Fuente Alamo, and indeed of the entire El Agar culture, is its unexpectedly advanced metallurgical technology. In an era when much of Europe was still transitioning from stone to metal, the inhabitants of this settlement demonstrated a remarkable mastery of bronze production that appears far ahead of its time. Archaeological evidence indicates that they were not merely using metal, but actively producing it with a level of consistency and sophistication that implies specialized knowledge and possibly even controlled production systems. Tools and weapons recovered from the site, such as daggers, halberds, and axes, exhibit uniform shapes and high-quality casting, suggesting that metallurgical processes were standardized rather than experimental. This level of consistency hints at the existence of skilled craftsmen or metallurgical specialists who understood not only how to smelt copper and alloy it with tin, but also how to refine and shape the resulting bronze with precision. The control of temperature, material ratios, and casting techniques required for such production would have demanded both experience and an empirical understanding of metallurgical principles, knowledge that is difficult to reconcile with the technological limitations traditionally associated with the Bronze Age. Even more intriguing is the question of resource acquisition. The production of bronze requires both copper and tin, yet tin deposits are relatively scarce and often located far from copper sources. This suggests that the people of Fuente Alamo were either part of a broader trade network or had developed logistical systems to obtain and transport these materials over considerable distances. If true, this would position the settlement not as an isolated community, but as a node within a larger economic and cultural network, one capable of sustaining specialized industries and long-distance exchange. Some researchers have proposed that this metallurgical sophistication may have been a key factor in the social hierarchy observed at the site. Control over metal production would have conferred significant power, allowing elites to monopolize weaponry, tools, and symbols of status. In this sense, metallurgy was not just a technological achievement, but a foundation for political and economic dominance. The presence of high-status burials containing finely crafted metal objects further supports this theory, suggesting that metal was both a practical resource and a marker of identity and authority. Yet, despite these advancements, the origins of this metallurgical knowledge remain deeply uncertain. Did the inhabitants of Fuente Alamo develop these techniques independently, through gradual experimentation and innovation? Or were they influenced by external cultures, perhaps through contact with more technologically advanced societies in the Eastern Mediterranean? The lack of clear transitional stages in the archaeological record makes it difficult to trace a linear progression, leading some to speculate that the knowledge may have appeared relatively suddenly, an anomaly that challenges conventional models of technological evolution. Equally puzzling is the eventual decline of the Elaga culture. Around 1550 BCE, settlements like Fuente Alamo were abruptly abandoned or transformed, and the sophisticated systems that had sustained them disappeared. There is no definitive evidence of widespread warfare, nor clear signs of catastrophic natural disasters. Some theories point to environmental stress, such as prolonged drought or soil depletion, which may have undermined agricultural productivity. Others suggest internal social tensions, perhaps exacerbated by rigid hierarchies and unequal resource distribution. It is also possible that disruptions in trade networks, particularly those supplying tin, could have crippled the metallurgical industry that formed the backbone of the society. Whatever the cause, the disappearance of Fuente Alamo and its culture remains one of the most compelling mysteries of prehistoric Europe. It represents not just the fall of a settlement, but the vanishing of a system that had achieved a remarkable balance of technological innovation, social organization, and environmental adaptation. Today, the ruins stand silent, their stones still aligned with the same precision as they were thousands of years ago, their secrets buried beneath layers of earth and time. In the end, Fuente Alamo forces us to reconsider what we think we know about the Bronze Age. It challenges the notion of linear progress and reminds us that advanced knowledge and complex societies can emerge and disappear far from the centers of history we typically recognize. Most of all, it leaves us with a haunting question. How could a civilization capable of such metallurgical mastery, architectural ingenuity, and social organization simply fade into obscurity, leaving behind only fragments of its once extraordinary existence? What do you think truly caused the civilization at Fuente Alamo to mysteriously disappear like that? Share your thoughts in the comments below.